Hello, hello people. What is that? Setup? What? Um, huh? There are some new settings on Twitch. Okay, seems good. Okay, okay. Sounds good. Sounds good. So we'll get started. That's it. We just get started. Let me just ping a few people. I guess I can. Oh. Wait. Yeah, let's go there. Hello people. Just gonna do a few things and we'll get the stream started. So starting the stream. Chunk collisions now working. So finishing them up. It's super duper fast. Okay. And here we go. Here we go. Volume, just checking the music. Yeah, okay, this should be good. Okay, so let's get started, shall we? It's a bit late. I'm sorry about that. It's like already 10 p.m. I guess I woke up very late. I woke up in the afternoon and I actually didn't do much. I just went running and stuff. Well, yeah. Well, yeah. And let's get started. So basically, since last time, what I did was I fixed my collisions. This was actually some very stupid problem. It was a problem in my generator. Well, I'm in here, I guess. And when I add box vertices, nope, not there. When I expand the box, with expand box Y, I just had a few values wrong. Like, for example, this was something like that, I think, before. This was plus, well, okay, this is plus plus and this is good this way. But yeah, basically just a few things kind of stupid like that. So I just fixed that. There was like maybe two or three problems, like small typos, you could say, due to the copy and paste. But yeah, I fixed that. And now, as you can see, well, actually, we don't have anything. Do I even have collisions? Oh yeah, I have collisions. So I have collisions on this chunk. And as you can see, when I move there, I have collisions. I have collisions there. I can't go right because of the block. I can't go there. I can go up. I can go there. Collision. Collision. Right, collision. I'm just changing the color so you can see more clearly. Right now, they're not updating in real time. But that's fine, right? Collision, collision. I can go down. Well, I can't because there's a collision, right? And everything is working just fine. We have a complex collision of the chunk. That's like very fast, right? I actually want to profile. I think that would be nice to see this. But yeah, it's working well. Very, very simple collisions that are working pretty well, pretty fast. There's just no sliding right now. Cuckoo! Cincinnati, how are you? Oh, wait. Oh! Oh! Thanks for the sub. Thanks for the sub. And yeah, basically right now I have collisions on one chunk, but not on the other chunks, right? I don't have collisions there. I don't have collisions. Well, I do have collisions here, right? But it's only on this chunk, and it's working well. But then we have to make it work for the other chunks, right? Us? Hey, Arcsaber. Hello, hello. Welcome back. So yeah, collisions are working. Chunk collisions are working. That's it. I'm gonna rename the stream. Chunk, well, custom chunk collisions now working for my Minecraft-like game. Woo! Crazy! So yeah, if you have like any question about the implementation or that kind of thing, feel free. And what? And now we basically have to make the collisions work for like other chunks as well, right? Not only the one at the center. And on top of that, there is also, yeah, I do have some. If I look there, now I can display my chunk like this, and you can see that we have collisions. Well, I can display the collisions like this. You can see that we have collisions on this side. On all sides really, but I'm only displaying one side at the moment. And you can see that like everything here is like alright. I don't really know why I have some problems there though. But like I might have some other problems, but you can see that it's like great. Like we have the terrain, right? That's a chunky chunk, yeah. Yeah, I don't know why it's like this. Like, there shouldn't be any hole here. Oh, actually, never mind, that makes sense. Yeah, it doesn't. No, I don't know, actually. It should be a big box. I don't know why it isn't a big box. But yeah. But yeah, I guess that's something. Yeah, probably a few problems still. But that's good. We have some good things. And until we find new problems, then we're going to keep this. And yeah, I basically have some delay to generate the rendering right now, instead of it being updated like every frame. But I can basically start it again, try to work a lot like this. Okay. And now we have the collisions for the different chunks. Or maybe. Well, it seems like there are some problems. So we're going to debug that. There's only one chunk that's good for some reason. Like if I go back to 0, 0, 0, 0 is very simple to see. It has like those problems with the generation. So it should be this way. Is it? Yeah. Just a bit more. That's no. Okay, it should be this one. Yeah, it's this one. You can see that we have collisions there with this chunk, but not the ones around. So yeah, we just have to fix that. That's great, man. I love it. So, what are we gonna do? What are we gonna do? Well, I mean, first, I think I want to push this because it's like a success. It's like a success. I managed to have chunks have collisions, right? So I'm gonna push. Let me go to the engine first. Here we go. I have so many things, but so many things I don't want to push. So first, the physics server, I want to push it for sure. Then we have... Yeah, I mean, I guess we have this one. I'm not actually using this, but I have to push it to compile. So, chunk, I guess. Then I have this one. Then I have this one. I have the register types, for sure. I do have this one. Oh, wait. Let me change the music. I thought to create a new branch and start with the player personality simulation from scratch. After like 2 hours, it wanted to abandon it and return to main. And I had to convince it not to. After one more attempt, no, after one more prompt, the results became better and it thanks me for not burying the branch. What the fuck? It's like a real... I mean, we're training AIs on people, right? And I mean, the amount of times I've seen people that wanted to remake their whole game or their system or all of that stuff, right? That's crazy. So I actually have a lot of files and I don't know if I actually want them. Let's go in this one. And this is the one I'm currently in, right? Yep, I'm gonna push this one. Boom. Voxel collision, I don't have this, right? Yeah. Cube chunk generator, this is still nothing. Voxel collision louder, this one is useful. Right. Like if I go there, I have a bunch of things that load the chunks. So that's good. Then we have, this is nothing. Voxel generation, this is nothing. Let me just go in. Yeah, that's nothing. Same there. Nothing, that's what I'm saying. And yeah, it should be good. Okay, it should be good. So this is... $33, maybe? And this is gonna be... Collider generated for chunks. Well, custom colliders generated for chunks. A player can now collide with chunks, basically. And well, only at 0, 0, 0 for now. Like only at 0, 0, I guess. I don't know if it's like 0, 0, 0 actually. I think it's like 0, 1, 0. Oh, because it might not be updating. Well, I have to debug that, right? That's like part of what I have to do today or tonight. This kind of coding became something like a knowledge management simulator. And it's fun in itself for me. Oh, knowledge management simulator? Interesting. I'm not sure how it looks like, but... I see. So what do I have to push? The player? Yep. Then we have... What do I have there, actually? Yeah, nothing. You know what? I'm gonna reset that. Am I? I am. Because I'm just checking this and I'm never really using it right now. I need to put the debug lines, I suppose. If I put the debug lines, that means I have to push the scene. And what about the project? Oh, that's fine. What about the torus? Yeah, I need to put some stuff. Okay, and now I'm just gonna push this. And colliders partially displayed. Oh, here we go. Okay, so I have a few problems with what I currently have. And one problem is the colliders should not be generated everywhere, but they still should be generated like for the chunks next to me. So I'm not really sure about that. Like if I restart and I don't open the editor and I put a breakpoint in on observer new chunk, I should be able to see the new chunks being added and stuff. So like there. I'm not going to breakpoint right now. But yeah. Ah. Boom. Okay, so here we go. And let's say we are here. So we have collisions, right? So now let's go here. And we're gonna move. I'm gonna move this way. And okay, new chunk. Here we go. I was a bit worried. So we go there. We have the closest chunk. We lock. I have things. Chunk depth. Size 1, yeah. I'm actually not sure about that. Exiting chunk found. You know what, let's just continue. So new chunk, oh, never mind, yeah, I got it. So I push this one with a depth of 1. Oh! Oh, that's why. It only finds one chunk, does it? Actually, no, it finds the ones around. Yeah, no, that's actually fine. That's actually what I want. So it's like 9 in total. I basically have 9 chunks, right? Well, 8. Wait, only the ones around? I mean, it should technically be fine. So we have some stuff, we can sort, but in the end, it doesn't even matter. So okay, it's sorted. Perfect. We have the indices. Huh? Well, okay. And we have the scores, I guess, which is good. We have one that is like the middle, and I'm not sure about that, but okay. And there is also, well, there is this chunk to spawn from, and we have the coordinates. We have 1, 1, 0, 0, 1, 0, and all of that. And that looks good. It's even looping around, now that you look at it. I still have to handle something about that, but it's fine. Is it? Well, let's say it's fine. Okay. So then, you have all of this, and at one point you have the thread generation loop, right? Or maybe it's already... No, the mutex is not looking anymore, right? So... something like this. Okay. Now, is it... Okay, this is loaded. Well, everything is going to be loaded, right? Oh, no, okay. So the chunk is loaded because it's been loaded thanks to the visuals, right? So data is already there. But now we want to register the new chunk, right? To the colliders, to the physics. So how is it gonna work? Oh wait, I did something wrong. That's fine. So I have the collider. This is static. And we have the vertices going from 50, 0... Huh? That's supposed to be the position, right? Wait, so 50 is like the minimum. But it's still supposed to be the chunk 0, 1, 0, right? Actually, no, it's X. So it's like 1, 0, 0. It's the chunk 1, 0, 0. Right? Like if I look at this. Boom. It should be 1, 0, 0. Cube chunk 1, 0, 0. Okay, that's it. So this is good. Yep. Yep. So I don't really understand what's wrong. So register collider. I push back. I add 2 static colliders. Then I say that it's loaded. And this is it. And this is good. And then we have this one. Who, this is a new chunk, coordinates 1, 2, 0. So if we look at the vertices, because that's what's really important, I don't have to look at the implementation for now. I can look at voxel collider, shape, vertices. Huh? Oh, because it's 1, 2, 0, right? Like 1, 2, 0, so it's like above, so it's like the air. There's nothing there, so that makes sense that it's empty. Okay. Voxel collider. So this is... Okay. I mean, it seems to generate the colliders fine. So I don't really understand that part, for sure. But if we go to... I mean, if I go down... Oh. New thing. If I go down, I go through, right? Which is a problem. So... yeah. So, voxel physics error. I have to check this. I have to test collision against all and put a breakpoint. Okay, so we have this. How many colliders do we have? 17. So that's like a lot of objects, isn't it? And we can see that it's like contiguous in memory thanks to the page allocator, which is nice. So iLoop. I should have a vector that sorts. Anyways, so I have the convex shapes, right? So this is a lot. The first one has like a lot of convex shapes. That's normal. No collision. So it's looping. Is it the same? Wait. This one has 32. This one has 55. So we have a lot of convex shapes per chunk, right? Because each collider is a chunk. And a chunk is made of multiple convex shapes. Wait. Yeah. Each collider is a chunk. The chunk is made of multiple convex shapes. Of boxes, basically. It's boxes. And ha. And what? Is this valid? It looks valid to me. Vertices 8. Like it's a cube, right? Well, it's a cuboid. Edges, normals. Axis to projections. So it looks alright. But for some reason it's not alright. And I don't know what to do about that. So let's go back there. We don't have collisions, but we do have some there, right? So this is like one chunk. Right, we have the collisions there. Not with the new blocks, but that's fine. We don't have anything here. Of course. Boom. And we don't have anything here. And what about the other side? I'm just testing again because I want to make sure that it's only the first chunk that is good. Okay, this one is not good. This one is good. So this one is good. And this one. Yep. So that's the limit. And... And is that 50? I think this is 50, right? Like if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I do that 5 times, am I going to reach the end? Like 1, 2, 3, 4. Yeah, okay. Should be good. So this is 50. 50 times 50. And the question I'm asking myself is, why is a surface okay? Why is it okay in 0, 1, 0. But it's not okay in the other ones. Because it's not even 0, 0, 0. It's like 0, 1, 0. So if I go down, you can see that this is... No, this is fine. Actually, let me go there. So you can see that we have a new chunk there, right? We have a new chunk. This is a new chunk. Because we are seeing the visuals. So if I try to go there, I have a collision. Because it's 0, 1, 0 and we have collisions there. But what about this one? We do have collisions. And the question is why? Why do we have collisions here? And they seem to work correctly. Which is weird. Why do I even have this, actually? No, never mind, it's fine. Is it? I mean, it shouldn't show faces on the inside, should it? What about the back face cutting? Did I remove the back face cutting? Maybe I removed the back face cutting. Oh. That's bad. But yeah, this is fine, but this one is not fine. Right? Which is weird. So 0, 0, 0 and 0, 1, 0 are working, but not the other ones. So it has to do with X and Z, it feels like. So. Let's go to the... To here. We have the generation here. I think there might be a problem with the generation. Or is it the... Yeah, I think it has to do with the collisions, because you can see that we have some problems there, right? I actually... Wait a second. What if I go... So this one looks like a big rectangle. Does it actually? It's a lot of little lines. Yeah. I'm not sure about the visuals either. Like if I try to go there. There. It doesn't change anything, right? I can't go inside. So this is working well compared to what the visuals show us. So the visuals might be wrong, is what I'm thinking. Oh, wait. Huh? Where am I? Oh, wait. I can go in. Oh, never mind. No, this is normal. Got it. If I go down. Can I go like here? No. Oh. Huh? Wait, I can go here. Huh? Wait, what? I can't go there. But I can go here. Can I go there? I can. Wait, is it good now? It's not. So I'm not sure about what's happening. Why do I not have collisions? I do have collisions here, but not here. So I do have problems with collisions actually. I still have problems with the generation. that it's not only due to the coordinates. Okay. Okay, this is important. So what I'm gonna do first is I'm gonna make sure that everything is fine. I was trying to optimize things, but instead we're going to try to make it work first, and then we're gonna optimize. So, yeah, I tried something, okay. But I'm gonna change this. So expand the box in X. Let's do it again. So we're gonna have the currents max X, right? Like this. While this is less than the maximum. Well, we see what to do? I guess we do have an index, but the index is going to be... Oh, we don't have the chunk anymore. Like, can I? Cards? No. Well, I mean, yeah, of course. Let's do that. So if it can be added to the box. Well, if we can't, we're gonna break. Well, if it can be added, we add it, and else we break. Okay, so this is pretty simple. I mean, I think the previous one was fine, but I want to make sure that basically I just want to compute the indices using cos.x. Wait, do I have the chunk? I have ndvoxels, right. So this plus this cos.y times this plus cos.z times this times this. Okay. Okay. And max x is the current one, right? So we're just gonna replace this one. So this one should be good, right? Like, it's very simple. Okay. So now we're gonna do the same with z. Okay. So now we should have big boxes. Because I think there is a problem with z, actually. Can I just look at it quickly and see if something is wrong? Not that easily. Yeah. So let's change that. We're gonna have this. We don't want the index. We don't want that. So then we have this. While this is less, then we plus plus. Then we have x, right? While x is less than the end, we plus plus. Then we compute the index using this simple formula. I love big boxes and cannot lie. Yeah, boxes. Bricks by bricks. Okay, so we have this here. We have x. And we have the index. And while this is more than chords.x, I think. Actually, wait, index. Okay, maybe I'm gonna do... Okay, let's fix this, actually. So this is good. Add to the group, else I try to remove. So instead, I'm gonna do while x is more than cos x. Then I do x minus minus, and then I compute the index again. Because I want to make sure that this is good, even if it's not optimized. Okay. So we have the index, and we do stuff, and it should be good, and it should be working. I hope. I think this was the problem, really. I think this was the problem, but I don't know how. I feel like the computations are fine, but yeah. I don't know why. And then we have this one. Ooh. Okay, so I'm just gonna copy this again. And I'm gonna replace this one. And I want to remove offset. I want to remove index. And while max y is less than this is good. We remove the offset, we remove the index. Boom. Plus plus. Yeah, that makes sense. Then we have the same here. We remove while x is less than and x. So this is correct, right? And then we compute the index directly there. How? Like this. Let me just check. So we have x and we have max z. Y is constant. And then we have this one here. With x. With z. And y is max y. Okay. Yeah. And then we want to remove faces and stuff. Ooh. So we want to remove x first. So this is basically gonna be the same as here. Right? So we minus minus x. Then we compute. So we have the index here. And then we remove. Sounds good. Remove face. Well, that's line. That's a line. And this one is the face. Remove face. And we are gonna have z. Wait. Which one is it actually? I think it's z. Z first. Then we have z minus minus. Then we have x. So I mean, from basically x equal cos.x. X is less than and x. And we do x plus plus. And then we remove from the group the thing. So computed with we compute the new index and we remove this index. X, z, max y. And this should be good. I hope. Yeah, now there's no reason it's not working. It's still not going to work, but you know, there's no reason normally. Okay. Do I have... Can be added? Yep. Can be added. Can be added. Yeah, it should be good. Should be good. I wanna see what the visuals say. Hmm. Wait. Ah! Okay. So, oh my god. What is that? So it's actually the same collider as before. It's like showing the same thing, which is crazy. So I don't understand. I have no clue. I have no idea. Oh, I was thinking, instead of like restarting the engine for debugging, maybe I should like make a button to reset the scene. But I feel like there's still going to be a few problems. Like I still have to reset my single stun and stuff, right? But yeah, I'm not sure about that. It feels like it's the same. So maybe something is wrong about the algorithm itself. Like, let me move around. Boo. Okay. I have the freeze, so I'm gonna switch. And we have... Huh. Huh, wait. What? So we do have some surface here. That seems to be... kind of alright, but we have some flying things. Why is it so far away, though? It seems to be kind of fine, but yeah. I'm not sure about that. Oop. And we do have something here. Let me switch back. And I'm gonna try colliding with stuff. Because the algorithm doesn't seem to be the thing that has a problem. Not, I'm talking about the collision algorithm. But it's really how I generate my things. So wait, this one is not... Wait, I'm on the wrong side. So, wait, what? Okay, it's this one. This one is good. If I go there... This is good. This is good. This is not good. Okay, yeah, no collisions there. I'm not really sure. OMG, hello, Repet! Why would you do chunk collision? Why not? They want me to go through my chunks. They want the player to just fall to their doom. Do you mean custom collisions? Basically, by chunk you mean block. By chunk, I mean all the blocks inside the chunk. Right, so yeah, it's like the blocks of the chunk, right, like this. It's what I mean. That's what I mean. But yeah, for some reason, this is still weird. Like the surface looks fine, but then below that it's like weird. You make collision for the whole chunk? Yeah. Well, basically it's very simple collisions. Basically I decompose the chunk into multiple blocks, into multiple cubes. So like, for example, if you have, let me open Paint, always, I'm gonna do a software, a Parrot software. So basically, let's say you have your chunk, and you have a lot of cubes inside, like, well, let's say you have this. Let's say you have this, right? Wait, what? This, wait. You have this, something like this, right? Let's say you have this, and you have this. Then instead of having a collision for each block, what I'm doing is I make a big box here, and I make another box here. That's why I only have to test two cuboids instead of like all the little cubes. So it's like very fast. That's what I'm doing. So like individual cubes don't really have a collider themselves, right? To optimize that. In that way, since it's like three-dimensional and it's not collisions with the faces, it's collisions with areas. Thanks to that, we can basically push a player out of the blocks if we want to. If like a player is inside, we can find like how to push him, how to push the player out. And it's good because sometimes, you know, in like some games, you can clip through collisions. But if you have this, then it makes it a lot more safe, a lot safer. Do not go like through collisions. I guess. The topic is wrong. I'm not supposed to have those holes. And I'm not supposed to have all of those rectangles there. Yo, Capcuba, hello. How are you? Yo. Do you remember me? Oh man, I'm not sure about that. It's splintered. Splintered. Wait. I'm not sure. If you tell me the context of how we met, then I'm going to remember. I don't remember name. I suck at remembering names. But if you give me the context, I will remember. I'm emulating PS2 games right now. Oh, my streaming is lagging. Oh. I mean, it's not moving right now. Don't worry. Well, except me. But yeah, what's the problem? Yeah, so I have different collisions there, different colliders, and they all stop around the same eighth. And I suspect that eighth to be to be what? To be the end of the chunk. Well, it's not really the case actually, but I don't know, man. I couldn't even fathom what the cause is. It's not just a block. Yeah, right? Like, basically for this chunk at the bottom, we're supposed to go from 0, 0, 0, expand that in X, then in Z, and then we go up. So why do we have holes here? Why do we have holes? I have no clue. So what I'm gonna do is I'm gonna restart. I'm gonna go to expand box, like, well, just there. I'm gonna put a breakpoint. And I'm gonna wait for the chunk at 0, 0, 0. Because the one at 0, 0, 0 shouldn't have any problem. There's no reason it has a problem. So we should be able to find the reason pretty easily. The reason it's behaving like that. And after we fix that, I'm sure we're gonna fix a lot of problems. Okay, so here we go. So the first chunk is not the correct one. It's 0, 1, 0. It's the first one that is being generated. Maybe that's why this chunk is good. Oh, do I clear everything? Wait a second. Is initialized. I'm not using this. That's fine. NB voxels. I'm setting this. Voxels is... Let me go there. No. Voxels, I'm setting this. Voxel to group. I'm resizing it. And I don't push back. And then we have this that we clear. We clear it. So the state should be reset correctly. Wait, do we... Oh no, I understand. I'm stupid. Okay, I get it. That's so stupid. It's because resize. Oh my gosh. It's because resize is setting everything to, well, all the new elements added with resize are going to be set to 0. But if it's already allocated and also constructed, then the current elements don't change. So basically we have to clear beforehand. So basically what was happening was the first chunk was LADS, oh no. Well, basically the first chunk was good, that was being generated, because this was 0 everywhere. So the data was right. But then for the second chunk that was being processed, it had the data from the first group. Drink. Duh. How many stuff you added? Oh, how that's so hard to read. How many stuff you added? Well, you weren't recommended on my For You page. Oh, gotta be hydrated, yeah. So basically, all I did is I continued my Minecraft game. I'm working on my Minecraft-like game. And I don't remember when was the last time you came. But I'm glad you came. And basically, I have my Donuts Minecrafts. I optimize things quite a bit. I can place blocks, I can break blocks. And I can also place blocks at the other end of the world, like over there. Like if you zoom a lot, you might see some pixels, some gray pixels, right? It's there. And same there, right? I can like everywhere, it's like instant, it's like fluid. And I could actually go there, like I could just move there. Look at this. The blocks are there, right? They're there. And I have some snow biomes, I have some cliffs, as you can see there, right? That I have to improve, but yeah. I don't know, but the blocks are way smaller than you. Yeah. They are. It's like far away too, right? And yeah, you can dig, right? Even though it's a donut, it still blocks. That's something I did a while ago, but yeah. There. I can place blocks on the surface too. And right now I'm trying to have custom collisions. And if we switch, we can see that now it should be a lot better, but it's not. Why? But cool. Thanks. Yeah, why is it not good? I was sure this was the problem. So let's go to 0, 0. I actually don't remember where it is. Let's move. We're gonna... Okay, it's there. We have 0, 0. So we have collisions here. What about here? Okay, what about the grass? So we don't have collisions. Okay. Yeah, we have another problem. But I'm also curious about this. Can we still go in the collision? But if I go down, we can't go in, but we can go in here. Okay, so this is a problem. Up. No. Yeah, that seems to be fine. What about this? No. I mean, this one I should be able to go in, because it's not generating collisions at the bottom for some reason. Yeah. It's like all this... wait, actually this one is generating collisions? Oh! This one is not, but this one is. This one is. And this one is. That's interesting. So let me restart. And I'm gonna check this again. But the first chunk is good. So that's a problem of cache, I feel like. I feel like that's a cache problem. I mean, I should have reset everything the way it should be, so I don't really know why there would be a problem. Okay, voxels to group. 0 everywhere. And the first chunk is good. Now the second one. It's not good. Even though I resize. So clear is not sufficient. I don't get that. There are some zeros there. But it's not what I want. I don't get it. You know what? Let me go here. So when I go here, voxel to group is still something like that. Now we clear. So this is a size of 0. And then we resize. And we have some values? What is that? And if we continue, it's still not being reset. I don't get that. Oh, maybe Godot is not initializing. Oh, maybe... I get it. So default behavior is... this will behave like resize uninitialized instead. That's why. Okay, I think that's why. So I have to resize initialize. Right. So this is actually a template. So is this trivially constructible? Yeah, okay, so I have to resize true. Oh, that's so stupid. Resize initialized. Here we go. Okay, that's very stupid. But okay, now collisions should be good. That should be good. Well, I still have one problem, but most collisions should be good. And the problem I want to fix is actually an architecture problem. So that's why it's going to be hard to fix. It's because my donut is looping, right? It's tiling. But right now, I'm generating one collider for each chunk, which shouldn't be the case. Because my visual chunks are tiling around, but my collisions, the colliders of my chunks are flat. So they're like in a flat world. Let me actually move around very fast. I have to generate visuals. Sorry about that. Is it good? Did it generate? Maybe it did. Yeah, it did. Okay. So let's go back here. Where was... Wait. I don't know where the start is. Okay, it's there. Maybe I've been going the wrong way. Anyways. So we have collisions. Right? And if we switch, we have... Yes! Yes! Look at this! This is what I want. This is a big quad. And this makes sense because the chunk that is underground has like... Well, it's like a big box, right? It's like a big collision box because it's like underground and every block inside is has a collision. And as you can see, we have the big box. So this is working. And as you can see, this one, the chunk on the left, is good too. Oh my god. Oh my god. This is it. This is it. This is working. Nice. So do you want to try the dot bat? The dot bat? Wait. Oh, I made the dot bat. When you open it, it makes your mouse shake. I'm not sure I want that for programming. Maybe not. So when I go there, I have collisions. I have collisions. Oh my god. Some crazy thing. This is crazy. Oh my god. Makes your mouse get a Caesar. Okay. Sorry, I'm just too happy that it's finally working. I've been on it for like 2 or 3 days. And this is working so well. We have like very precise collisions, right? It's like working for like a lot of chunks. And I can also... Let's go to the physics server. Test collision against everything. We have... Wait. Let's go there. Let's go there. We have... What the heck is that? Okay, we have 200 colliders. We have more than 200 colliders. And look at how fast it's going. It's like so fast. There's like no problem at all. So what I want to do right now, I might crash. This is a warning. But I want to profile that. I want to profile. So please don't crash. Why is this so laggy all of a sudden? This is because of Tracy. But okay. Shit. Shit. Stop it. Stop. There is a big problem. Okay, 10 gigabytes left. Okay, that's fine. We prevented the crash. So now, Let's go in. Okay, we have all of this. We have draw a pack. Sounds totally safe. Yeah, right. So we have a lot of draw a pack, but that's not really the problem. Well, that's not actually what we want to check in the first place. Okay, here we go. Wait, what? Well, okay. So we have all of this. And we have multiple collision. Oh my god. Sorry, this is, how many was that? 2,000. But this is like 27,000 for like against all. And we have how many steps? In one frame, we have 1, 2, 3, 4, 5, 6, 7, 8. Wait, this is crazy. I mean, okay, yeah, it's because my frame rate was pretty low because like it's like there are just so many checks. I totally have to remove some. Let me go there. 200. Yeah. Test collision. I feel like I have way too many collisions. So I'm not supposed to have all of that, right? How many colliders do I have? I don't have that many colliders. I'm not supposed to have all of this. Huh. Well, it's still like pretty fast. It's like 900 nanoseconds for a collision. Look at this, 900. This one is like 500 nanoseconds. Oh my god, this is just... Everything is just so fast. I love it. This one is like... I don't even know when... I don't even know what comes after nano. So... Milli. Micro. Something, right? Wait, what is actually between the two? Milli, micro, nano. Maybe there's nothing? No, there is something. Never mind. So it's micro. Wait, it's micro. So I guess this one is like 1 microsecond. This one is actually big. Ooh, it's so big. It's 1 microsecond. Ooh. Ooh. Okay. But yeah, we have a bunch of logs, and that makes it very slow. So I totally want to remove that, because that's consuming my CPU, and it's gonna crash the stream at some point. So, test collision. I mean, no, that's not the problem. The problem is that I have that many collisions. I'm not supposed to have that many collisions. Why do I have that many collisions? Test collision against all. So for each collider, right? So if I put something here, this is 200. Oh, it's because each chunk has convex shapes. I forgot about that. Okay, that makes sense. So if I do a quick computation, like 211 times 269. Nice. And we have a lot. Take a break, bro. Hey, I did. I took a big one. One that is too big, so I have to do a lot now. So wait, this is 27,000. Okay, so that makes sense. That makes sense. Okay, that makes completely sense. So I'm just going to remove a few things though, because this is way too much. I'm going to remove a few checks. I'm going to keep this one, right? I think this is important. And I'm going to remove the stream for like 8 hours yesterday. No, 11 hours. But yeah, I took a big break though. I'm not lying when I say that. I guess I have this, right? I have like multiple checks there. I mean, I know that this is supposed to be instant. I'm not going to have something here. And maybe I want counters or something. Add. I mean, it's adding if it's not being registered. Do I want to keep this? I'm not sure. I'm gonna remove this though. So get. I mean, most of those are just get, right? So test collision. Do I want to keep test collision? It's like too much, right? I think I'm gonna... Let me think. I'm gonna keep the add. Update convex vertices. Wait, what's that? Update convex vertices. Oh, okay, no, that's fine. This one is fine. And I'm gonna remove this one too. So this is a slow path. I'm gonna keep this one. This is... the slow path. Okay, it should be good. And we have collisions, that's crazy. Okay. I had to think a little now. Because now it's an architecture problem. So maybe I want to draw a lot of things to solve that. Maybe I want to make a document to solve that. Yeah, I want to write some stuff. I'm saying you're writing your own profiler. I'm not. I know I'm remaking everything, okay? But I'm not remaking my own profiler. I mean, technically, okay, I'm adding some macros, basically, that are... Well, basically, I'm just adding the macros that are showing the functions. But that's it. That's what I'm doing. Okay, so now I'm just gonna restart with like editor, and I'm gonna push this because this is a big success. What? Yeah, so status, I'm gonna push this, I'm gonna push this. Big that's success. Yeah, that's success. For sure. So voxel 33.1. And this is colliders now working for all chunks. Exclamation mark. But not styling yet. Boom. Here we go. And I'm gonna discard because I think this is taking a lot of space. And I want to run this. And whoop. Okay, so we have this, and we can try to collide. I can go like there, for example. I can collide, right? Collide. Ooh, I'm colliding. This is great. So now I'm going to stop. I'm going to close. Why are you trying to sabotage him? Looks collidable. Yeah, it is. It works well. It works really well. It basically works perfectly for like different convex shapes. And it's like optimized for chunks in particular. So I have too many threads. I have the rendering thread, the render thread. I have the thread that loads chunks visually. That's like very busy, I guess, but that's fine. And I have the main thread that is executing the physics. And as you can see, we have like a huge delay. Bro is full-time streamer. I mean, nah, I'm not. Well, I mean, maybe I stream. How many hours? Wait, a full-time job is like 8 times 5. It's like 40 hours a week, right? And like, what did I do this week? I think I haven't streamed for like 2 days, 2 nights. But we have 10, so 11 plus 7 plus 5 plus 5 plus 9, I guess. And maybe, well, let's just do that. And it's like this week I've streamed 37 hours. Well, actually, you're not wrong. Well, in France, a full time is 35 hours. So I mean, technically, I guess technically you're not wrong. Technically, you can say, like, I mean, the only difference is that I'm not paid, but well, right. But technically, I guess you can say that I knew it. You can say that I have 2 jobs. It's like more. I was gonna say a hobby. Well, it's not bringing really money, right? So not really a job. I wish it could be though. And yeah, as you can see, we have collisions there, and then the thread waits a lot because it's waiting for the rendering to finish. It's waiting for the rendering to finish, and as you can see, it's like very fast. It's like very fast. You have 2 physics frames there, and we test collisions against all chunks, and it's like not even 1 millisecond. I mean, it's actually still slow. Now that I think about it. Wait. Add frame delay. Physics. Do we have... What's the end of the frame? Run. Well, I guess it's fine. What is that? Server process. Anyways. Wait, why? Why is it so long? Oh, because I'm moving the player, I think, there. Oh, I don't know, actually. What? Player.gd. Yeah, it's the player. It's in the player. And yeah, this is crazy. Because I'm not even unloading the chunks, right? I'm not optimizing that much. I still have opportunities to optimize this. And actually it's kind of slow, isn't it? I mean, I can optimize things a lot with the player because the edges and the normals with the world are the same. Because the player has like some cuboid kind of collision shape that aligns with the world, so I don't have to test everything like that. I can optimize it a lot. And wait, now that I think about it, my code was good. Like here. This was good, so I don't even need this. I can actually optimize it a bit more, technically. Well, I'm not sure if it's like really optimizing, but it's like something I can do. And Yeah, I really have to think a bit more about it. I have a lot of convex shapes. I mean, I guess the goal would be to cut because it's too slow, actually. Like 500 microseconds is too slow. I have to... Like, technically, I shouldn't have to test collisions with the convex shapes that are not in the chunks the player is currently in, right? And that should optimize, like, if I have 200 chunks, I think I had 200 colliders. If I have that, then that means I'm gonna test with only 1 or 2 instead. Maybe, I guess the worst case is 8 colliders. So we should be able to reduce the performance cost by 200 divided by 8. Let's divide by 10 instead. So 20? So basically it's like 500 right now, microseconds, but it has the potential to go down to... Wait, what? So instead of 500, well, no, instead of 200, it's 8. So yeah, we can get it down to 20 microseconds. And it's like microseconds, not milliseconds. It's like microseconds. So that should be pretty good. That should be pretty good. And we can also have like giant shapes. Well, basically not, never mind. Yeah, okay, that's pretty good. Okay, I'm glad. I am just checking this because I'm just so happy. But now we actually have to work. I think when you make games, it's like very easy to get caught in... Oh, I have to sign in again. Wait a second. It's very easy to like get a bit too happy and like spend time playing your game or something like that, when you should be working and like programming, I guess. I don't know why Google is asking me to verify my identity that much. Oh no. This. Please send me a code. Please. Get your phone. Open the settings app. Tap Google. What? I have to do that? Tap Google. I'm gonna... Tap means to eat. To hit in French. So I'm gonna hit Google. Sure. Manage your Google account. Wait, that sucks. I can't even find it. Oh, Google. Huh? Choose your account, tap manage, no. Select the security tab. I don't want to do that. Wait, what? Huh? Get a verification code? Tap yes on your phone or tablet. Device can't be reached right now. What do you mean it can't be reached? Why can I not do that? Huh? Okay. Let's do this. That means I have to enable my sim. Sorry about that. Now it's gonna load everything. Because basically, since I'm in Japan, I still have my French SIM card for things like that. Wait. Okay. Don't ask again. Yeah, it's been asking me so many times recently. Okay, good. So now we have Voxel game. Here we go. So, where was it? Yeah, I want to write. Voxel collision. Boom. So I'm still going to ask some questions to myself. What do I want? No. Okay. So now. Now. Collision handling. Well, simple collision handling. Well, convex collision handling. Like, yeah, I mean, well, physics system, right? Physics system implementation. Okay, and now this is a new question. This is about the loading. So it's not only about the collisions though, but I'm still gonna put that there. And this is loading colliders. So problem. The problem is that even though the world looks connected visually, collision-wise, the world is flat and infinite. This is good because we can optimize collisions this way by having flat colliders and we can mesh them, right? Sounds good, right? But the problem is it's currently only generating one collider for each chunk when we want. So what we want is when we want to generate multiple colliders at different positions for the same chunk, right? So it gives the impression it tiles correctly, right? So basically, what we have right now is we have a box there, which generates colliders like this, right? Like chunk by chunk. But because it's a torus, there is a limit. There is a limit in 0, and there is a limit, like a max limit somewhere, right? And it's like not looping, and that's a problem. That's a problem. And we want to generate So how to solve that? How to solve? So we want to generate, I think it's chunk colliders. I think we want to generate chunk colliders on demand. Chunk colliders on demand around the player's collider position. Okay. Sounds good to me. I do want to be careful about my memory, because if I spawn a new chunk collider object, yeah, I'm not sure about that. Actually, I'm not supposed to have that many colliders. Well, it depends. Okay. Oh, I have an idea. Then we want to generate the chunks if they are not generated yet, which is already the case. So yeah, and then we want to create the actual colliders used for physics, right? And the problem is this part, because right now we actually, let me restart Godot, because I modified this, right? And I want to make sure that this is working still. Oh, wait a second. I actually want something. I actually want to add some profiling. So I have the generate. Boom. And then I have, yeah, let me cancel. Can be added to box, expand. I mean, technically, I'm not supposed to have that many boxes, right? Well, it's only supposed to happen like one time. So I might put something here. Well, one time. Yeah, it should be good. So we have this. Well, one time. We have this, we have the expand box X. And let's say this is fine. Okay, so the problem is actually, as I said, in the voxel collision loader. And yeah, it's because we are loading the chunks first, right? We are loading chunks instead of chunk colliders, the chunk collider objects. And I'm not even using those colliders anymore right now, and that's a big problem. I sort, no. Yeah, I'm just getting, yeah. Let me look at what I, like the data I'm generating. Processed chunks. So yeah, this is like a list of chunks, not even chunk colliders. So that's what we should change. Okay, here we go. I'm gonna open the profiler again and just profile this. So if I go there, well, actually no, wait. Yeah, we have colliders there. So I'm going to move like this to generate a lot of colliders, and it should be fine. Stop. Please don't crash. Good. The stream is still good. So we have all of this. And I want to find... What do I want to find? Records. So this is main. This is the main thread. Yep. That's collision against all. Big weight. Oh, this. No. Oh. No. Oh, here. We have something here. Oh, no, that's a draw. Never mind. It doesn't count. I actually don't know. Wait a second. Is it actually profiling? It is. Oh. So generate happens there, and expand box happens mainly... Oh, never mind. That's a difference in speed. Oh, that's nice. So basically, it's rather stable, expand box, but generate kind of depends, right? And if we go there, for example, like here, can I go there? Can I actually move there? Like 174. 174. How can I go there? Wait, 17 milliseconds? Oh, no, never mind. Right, that's the speed. I want the position though. Histogram. Total time 34 milliseconds. That's still a lot. Yeah, can I just check it? Find. Oh, here we go. So, oh my god, so many debug things. The time from start, let's go there. 30 seconds. Where am I? 30 seconds. Huh? Milliseconds. So wait, 13 seconds. Around there. Right. Oh, there. No, that's visual loader. Well, I mean, it should be here too, though. What's that? No. Huh? It's not even visible. Execute pipeline, no. Wait. Yeah, because it should... I should have things here. Oh, but it's like another thread, isn't it? Oh, it's like running on another thread. I forgot about that. Wait. It was... Oh, no, never mind. Wait, what? 1, 2, 3, 4. So I have the main thread. I have the one that generates faces. Or like... Complete visible... Wait, what? Well, for the rendering. I have the one that... Well, the one from Godot that does the render. I have one that generates cubes and stuff. And I don't have another thread. So wait, I'm supposed to have another thread, but I don't have it. Why do I not have it? Huh? I don't have my thread. I'm missing a thread. Godot, I'm missing a thread. Never mind. In Tracy. Wait, that's so slow. Is it gonna crash or something? I still have this though. But where is it? Expand bugs. Wait, let me go in. So I have this. Do I have the thread? I have it, but... Okay, so anyways. So let's say we have that. Execution time 1 millisecond. It's still a lot. It's still a lot. And I'm not sure I can optimize this. I'm not sure I can optimize the time this is taking to generate the bugs. So this is my main worry. But I mean, I guess it's multi-threaded, right? So since it's multi-threaded, I actually don't really care about that because it's free. If there are enough CPUs. Yeah, let's say it's free. Okay, anyways. Okay, so everything is good. Way! Perfect. So now we want to load it. Okay, right now we are loading the chunks, but we shouldn't be loading chunks. We should be loading something else. So I mean, the approach is good. I think the approach is good. But the problem is that it's not good. Is that this thing is only loading chunks. And I mean, it's fine, right? But at the same time, not really. I'm glad that... Well, I think this algorithm is nice. I like it. But it's not what I want right now. Well, it might be what I want, but with it's the wrong type. So instead, maybe I might actually using things get neighbor chunks. Aside from this, do I have anything else that is using the fact that it's a chunk? Because if not, you have been streaming for 24 hours. That's impressive. I haven't. So wait, let's do chunk arrow. So get neighbor chunks, and that's it, basically, right? So that's all I'm using this for. So if we can have instead a struct with the neighbors, pointing to the neighbors, then it should be fine. Pointing to the neighbors. Like void star, maybe? Like a span of void star. I'm not sure about a span, but yeah. I'm not sure what you think about it. But if I can remove the fact that it's a chunk, then it's going to be great. Cube chunk, I'm not even using this, am I? Yeah, I'm not. This is perfect. So I'm gonna remove it. What about the space? I'm not using it. Perfect. I'm gonna remove it. And then we have all of this. And instead I'm going to push I have no idea. I have no idea. No, I kind of do. What about threads? That's my question. I mean, let's say it's not thread safe. Then then we're gonna have let me actually maybe push what I have. No, okay, that's fine. So we're gonna have a struct that is going to be chunk abstract maybe, or like chunk Dijkstra we can have in here. We already have a enum actually, so we can have a struct, a chunk, well, abstract chunk, and it's going to have a chunk that is going to be a void star. And the neighbors. And this is going to be a span. Yeah, now I'm using spans everywhere. So this is a span, right? Of void star, that makes sense. Yeah, this is good. And yeah, that's it. And we should basically be able to replace chunk by this. So let's do that. Maybe. Wait, actually, I guess this can be by copy. Can it? I have to think a little about this. But start, we have one chunk and we have the span. Yeah, I mean, this seems good enough. That's why I don't have allocations. This is fine. Wait, last chunk processed. Right. Right, wait, so it's not that easy, is it? Actually it is. Isn't it? Yeah. Maybe with this. Right. Or like, I mean, we can help. We can have this default. We can have this default. And then we can have another constructor that takes a chunk, PTR, and we can initialize our current chunk with it. Like this. Can I just have it in one line? No. Okay. Good enough. So, now we can just do equal, and that's fine. Good. And now over here, this is the wrong type. I'm gonna have an abstract chunk. Then we have the neighbors, that is chunk.neighbors basically. And we can remove, right? Then we have the same there. Chunk. Actually, let me think a little. No, that's fine. Yeah, that should be fine. Neighbors that size. Yeah, I mean it was abstract in the first way, right? So it should be like pretty simple to do things. So this is chunk.this. Yeah, it's just a reference. So chunk.neighbors. Wait, what? Oh, right. Oh, right. Oh, no. I forgot about that. I forgot about that. Okay, maybe this is a bit difficult actually. Because I have to access the neighbors as if they were abstract chunks, right? Should I have mass and Newton unit conversion in my Flappy Bird game? I don't think you need to. It depends on how you want to, change it from the original, right? But I mean, it's just Newton, right? So it's like not very complex. So I mean, you can always have something like that. But I wouldn't say that this is necessary by any means. Do I want a function pointer to get the neighbors? That could be something. So what should that be? Because if it's a pointer to this, then, well, if it's a span towards this, then, I mean, we don't actually need the chunk, do we? We actually just need a class that gets neighbors. Actually, we don't even need that, right? Do we? Get neighbors. Well. Not really, though. So we can even remove this, technically. We just need an identifier. So I mean, okay, maybe we need a pointer to have like the identifier, but yeah. Let me think. I mean, I guess as long as I have the neighbors like this, it should be fine. But at the same time, I don't really need this for like cube chunks. Well, actually. I mean, the graph is gonna take some place, but... Okay, let's do that. Let's go with this. So then we have the neighbors. Like this. Abstract chunk, yep. So we have the neighbor. We check if this is null, so... If this is null, then I request a load. Then we have chunk dot, or like, what was it? Neighbors dot size. Yeah, chunks dot neighbors dot size. We check this, and I mean, it's basically fine, right? So we have all of this. The only problem is that I need, at least temporarily, I need... How do you call that? Well, a graph. I need a graph, a connection graph. And basically I have multiple connection graphs, and that's like the thing I don't like. Can I... Okay, I'm gonna think about it. Problem. When generating stuff, chunk, colliders, well, chunks, chunk colliders, chunk visuals, etc. Would it make sense in a game with physics? Yeah, it would, definitely. But like Flappy Bird is just, I mean, with physics, it kind of depends, right? Like Flappy Bird, you basically just go up and down, and you have like the gravity and stuff. technically, I mean, I guess, yeah, technically you can have a mass that you can change. You can like make it more specific, but basically changing the mass is kind of the same as changing the gravity, right? Because in Newtonian physics, you have like G times M, right? Like the mass of your object, and like G is like the gravitational thing times the mass of the Earth. And do you have divided by the distance squared? I guess it's already in G. So basically, instead of changing the mass, if you just change the gravity, it's basically the same. So usually you don't really have that in that kind of game. But I mean, you can have it. Like if you want different... Wait, what am I talking about? All objects fall at the same speed. Wait, what am I talking? Well, all objects of the same... Well... Objects with different masses fall at the same speed. So wait, it doesn't have anything to do with that. So yeah, the mass is actually not relevant. Yeah, what am I talking about? The mass is not relevant to gravity. Like, it's only relevant if you have like a force, like I don't know, like an air conduct or something like that. Or maybe friction. That kind of thing. So when generating chunks and stuff, I end up using a graph. A connection graph. Connectivity graph. I don't know how to call that. Connectivity graph. A network graph. Yeah, connection graph. Okay. So the problem is that for different systems, visuals versus colliders, I need to create... Well, basically, I have different graphs, but I have to recreate the graphs. Is that a problem? The first question is, can we share the same graph? Can we share the same graph? Not really, because basically it's a no. For visuals, neighbors are looping, right? It's like tiling. Well, it's like looping. Whereas for colliders, it's not. Unless you want to keep track of the player's mass. G times M equals waste. Yeah, it's like the waste, right? But it's like not used for your falling speed, is it? I don't think it is. It's not, because in the equation it's supposed to discard the mass. What was it? Because that's for sure that that like all objects fall at the same speed. So like even if you have a force, like the force is supposed to be the same. It's not about the force, it's about... Wait. Because when you compute the force, you... Don't you... Wait, do you divide by the... Mass force? Yeah, that's it. With like the fingers, right? Formula. F equals ma. Okay. But... Wait. Why do all objects fall at the same speed? Formula. Basically, you have this, right? Yeah, that's it. That's a good explanation. So wave is the only force acting on the object. Well, in this case, if you have like no other force, like friction and that kind of stuff, I guess, then you have F equals mg. So that's like g is like the force of the planet, right, on the object. And so like you have the mass of the planet and stuff, right? And then when you move the object with Newton's second law, you have F equals ma. So then you have the acceleration equals the force divided by m, and the force is mg, so you have mg divided by m, so you just have g. So that's why it's not used. It's only used if you like apply the force against an object, for example, or that kind of thing. I still about it's not about Newton, but there's something about physics that I still don't understand. And I tried looking a little bit. If someone knows, please tell me. But it's about orbit. It's about orbits because I want orbits in my game. And I don't understand the logic of it. I don't understand it. I don't understand how it works. Like, why is the object not falling? Technically, I know what you're gonna say. If you think about it from the Newton perspective, it's basically always falling, right? It's always falling, but it's just that since you move at the right speed, then you fall, but like you keep the same altitude, right? But if you have like Einstein approach, with like everything is relative, and like the space is bending, why is the object not going towards the center of the... Let me show you. Orbit, Einstein, relativity. Like this, right? Why is it not falling? Right? I don't get it. Because, okay, you can continue to turn around, but, you know. I mean, I know that if you what? I know that you have, like, bicycles, for example, right? I think it's, like, kind of behaving the same way. It's, like, always turning, and you have, like, some gyroscopic effect that prevents it from, like, falling too easily, right? On the other side. But I don't understand how that works. I think it's because of the mass. Wait. I guess my math is wrong. Oh. Isn't that center of mass doing that? I don't know. I mean, as I said, I don't know, so I can't say it's wrong, I can't say it's right. Let me ask GPT, because I'm very curious about that. Wait. So let's go there. And we have explain why objects in orbit are not falling. I understand the Newton well. The explanation from a Newtonian perspective, but not from Einstein's relativity. If space is getting bent, isn't it supposed to follow the curve, like the slope of the curve? What is the slope? And a bit of chaotic collisions from years ago. What? The famous bowling ball on a rubber sheet. Yeah, maybe. I don't know. It's useful, but it also creates exactly the confusion you're having. What is that? What? Orbit. I think I understand. Yeah, okay, this is it, right? This is like how you see it. The key insight is objects in orbit are actually falling. Slope? Slope is something else. What? Slow what? Slow up? So why is it falling? Well, why is it... What? What's happening? The famous no. I mean, I think I actually understand. It's about time, isn't it? Because it's bending space-time. And if you have a vector, instead of... Wait, isn't time... Like, when you move, are you not supposed to be faster? Or like slower? Wait. I don't remember. Like, time is supposed to be slower when you move, I think. Oh, that's the opposite. Maybe that's why light is so fast. Wait, what? Wait. If an object is moving, is its time going faster or slower? Its time goes slower. Okay. So... Yeah, its time goes slower, but that means it's going faster relative to... Wait. That means from the viewpoint of... Wait. To a stationary observer. Wait. So if it's going slower, then it's going faster. Okay. Yeah, so if it's going faster... why is it going faster? I mean, okay. Wait, actually I'm curious. The faster an object moves, the slower time takes for it compared to someone who is not moving. Yeah, okay, I know that. Yeah, that's what I thought. Because, let's say you have a velocity vector, and let's say that velocity is the same, and that velocity goes through time too, because it has a time dimension. Then if you move, that vector is going to get bent towards like the positional movement, and it's going to reduce the speed you are going to move in time, right? I think that's why, something like that. So the thing is, if you move in orbit, that means time is slowing down for you. Like the object is going slower, right? Like this. And instead of going down, the vector goes... I actually don't know. It's not supposed to be that effective though, right? I'm saying nonsense. So they are falling. But they are falling along the straightest possible path in curved space-time, not sliding down a hill in space. They really don't want to be gay. That's crazy. They're doing everything they can not to be. But they are falling along the straightest possible path in curved space-time. The straightest possible path. Okay. Not sliding down a hill in space. The important word here is space-time, not just space. Yeah, that's what I was thinking about. That's why time is important. So in Newtonian physics, you have this, and you have, constant free fall and all of this, and it's good, right? Easy enough. With Einstein, you remove the gravitational force. Mass curves space-time. Yeah. Objects with no forces acting on them. Objects with no forces acting on them simply move along geodesics, the straightest possible path in that curved space. So you have the geodesics going through in that curved space-time. So let's say we are in 4 dimensions. Well, technically, I guess we can say that. So 4 dimensions. So the straightest path in 4D, in space-time, is just moving towards time. I guess. Okay, I guess. The geodesic is just a line towards time, right? Like a vector towards time. Like a... Yeah, like not a force, but yeah, okay. The satellite is not being pulled. It's simply following a geodesic, right? Like the time geodesic, right? But... that's also the speed, right? Why doesn't it slide down the slab? Because the rubber sheet picture is only showing space. Oh! While general relativity is about 4-dimensional space-time. If only space were curved, that should be right. It will. But general relativity is not about that. The curvature is mostly in the time dimension, not the spatial one. So okay, that's what I was saying. Basically, you have your vector, and I guess like moving... Wait, but then you have the... So I think I have the right idea about the vector, like the geodesic it's moving along, but I don't have the right representation of the space, of space-time in 4D. Yeah. This is small. Time curvature is much larger. I mean, yeah, that makes sense. Time is bent. Yeah, just imagine a imagine a 4D landscape, okay? Instead of moving only through space, every object is always moving through time. Yeah, it is. In fact, everything moves through space-time at the speed of light, roughly speaking. Wait, at the speed of light. Whoa. Okay. So wait, everything moves through space-time at the speed of light, roughly speaking. So it's not really. Okay. Well, roughly. I'm not sure about that. Earth bends the time direction. So it bends it, okay? Your natural straight path through space-time therefore appears, when projected into space, as an orbit. So... I go through space-time. I think I understand a little bit. It's like hard to visualize. Imagine flying north on Earth. You're going perfectly straight. Oh! It's like non-Euclidean space! Oh, I get it now! Because it's very hard to imagine 4D space. But it's very... like, 3D is a bit hard to visualize. But like, the surface of Earth is 2D, right? It's like a 2D non-Euclidean geometry, right? It's like very easy to visualize that. So you can basically reduce the amount of dimensions, and you can visualize it in 3D. From your perspective, you're going perfectly straight, and someone looking at your path on a flat map sees you following a curve. Yeah. Space, like Star Wars? Yeah, like Star Wars. Did you turn? Nope. The surface itself is curved. Okay. Exactly the same happens in space-time. The satellite is not turning because of a force, it's going straight. The geometry itself is curved. Why does the orbit stay at the same height? Isn't the path of steepest descent? Is the path of maximum proper time. Maximum proper time for massive objects. Think of an airline route. The shortest path between New York and Tokyo is not a straight line. It's a geodesic, right? I know that. It's a great circle. Likewise, the shortest, straightest path through curved space-time around Earth is often an ellipse. Oh, right! Wait. The orbit is a straight line, okay. Because the velocity is basically affecting the time dimension. Well, it's like affecting multiple things, I guess. While falling and orbiting are the same thing. Okay, this one is gonna be good. One jumps straight towards Earth. One jumps sideways very fast. Never feel gravity. Both are weightless. I'm not sure about that, but okay. The only difference is that their initial velocity sends them onto different geodesics. But jumps straight towards Earth. But it's like not taking into account like the gravity you have by default, right? One geodesic intersects Earth, the other loops around Earth. No force is needed. But it's falling. It's actually following the path that space-time wants. Wait, standing on Earth's surface is not natural. Orbiting is natural. Okay, so orbiting is natural. Wait, what? Yeah, I mean, it makes... Oh, wait, no, that makes sense. Oh, it's like my... Oh, I get it. It's like my game. My game has like the space that is distorted, and if you go on one direction, you just continue to go in that direction, right? Wait, but you can actually also leave orbits, right? So that's not good. Never mind, that's different. A person standing on Earth is continuously being pushed upward by the ground. Yeah, I mean, I know that. Geometric viewpoint. Gravity changes velocity. Gravity changes what straight ahead means. The moon is actually falling towards Earth due to gravity, but it never hits Earth because of its high sideways speed. Tangential velocity, I read. Yeah, but that's like using... I mean, yeah, that's a simple explanation. It's not hitting Earth because it's in orbit, right? But the question is, why is orbiting preventing the moon from falling on Earth? That's the question. It's not about, well, basically it's like you can ask the question, how am I streaming? And I can answer, well, I'm just using OBS and I'm streaming. But then you can ask, yeah, but how does OBS work? What are networks, right? And that kind of stuff, right? I'm basically pushing a bit more. And I still don't get it. Explain orbit with relativity, like with general relativity. And I'm gonna look at tests. Let's look at this. Mercury's orbit. An oval shape. Oh! Wait, that's nice. So it basically... Mercury's orbit proves Einstein's relativity because it's not a sphere. That's fun. Hey. Okay, let me go here. So much text. So much ads, so many ads. Wait, it's not ads, actually, it's part. Wait, what? Orbit. Mercury's orbit. I don't really want that, I just want orbits in general. I don't want Mercury. How does orbit make sense with general relativity? Who have the invisible fabric of space-time around them? Planets simply follow the natural curves. Yeah, but why? The path of least effort. Okay. Try to travel in the straightest, shortest line possible. Planet orbit in general relativity. So geodetic trajectory defined using... Wait. Oh, that's an answer. Yo, hey, Sarun, how are you? I'm spending way too much time on it, but I really want to understand it. Maybe if I watch a video, it would be better. They have residual... Oh no. If a net walks straight forward on a curved space, it will follow a curve over the surface. Yeah. Scale that up to 4 dimensions, and the curvature of space-time means that the Earth, traveling in a locally straight line, follows the curve. In other words, the Earth is just going straight. Just ask AI to teach it like a toddler. I mean, I did that kind of, but it didn't work well. I think I had a misconception about that, about orbits. I'm late, my bad, that's good. But how are you doing? I hope you had dinner. Yeah, I did. It was nice. Ask Claude. I've never used Claude. Well, Claude, I'm not sure about that. But it's not about that. I really want... I don't want it to be explained like a toddler because it's going to give like... similar things, right? But I want a very specific definition. Well, definition. Thing, I guess. I don't think there's really a way to visualize it easily. Well, except what it already told me. But it's not enough. I think one misconception I had was that if you do that, if you have an object, you have your planet and an object. If you go this way, if you go this way enough, you're leaving orbit. That's what I was thinking about. But I think this is wrong. Because it's per time. Oh, thanks. I just had like an Indian version of chicken and rice. Oh! And let me tell you, I'm the best cook there is. I mean, I like cooking. Oh, I mean, it sounds good. I would definitely eat that. And the side's velocity comes from the massive giant impact hypothesis? What? But yeah, basically some misconception I had. Biryani. Sure. Oh wait, that's how it's called? It's like, oh my god. It's like, how is it called? How is it called? The thing with the rice, the yellow rice. Famous dish with yellow rice. You have... Huh? Not that yellow rice. La paella. Or risotto, I guess. I guess I'm used to those. But what I don't like with the paella is that, la paella, I guess in Spanish, is that I don't like the seafood. So if you just replace it, so yeah, this is completely different. But, well, actually, yeah, if you replace the seafood by chicken, then, oh my god, yeah, sure. I mean, yeah, sure, I would totally eat that. It's chicken and rice cooked partially, then cooked together with saffron milk, rose water, cashews, fried onions. Ooh. Okay. I'm gonna keep the name. I'm gonna note it somewhere. Boom. And yeah, I think the misconception is if you apply a force all of a sudden, like a an impulse force, as they would call it in Unreal, like this, like very big, then it's actually not going to leave orbit. It's actually just going to go in orbit. The speed in the orbit is just going to change, right? I think this is a misconception I had that prevented me from understanding. But if you continue to apply the force in the same direction, like if you're here, that means you're going to move that way, and that means you're going to get out of the geodesic of the orbit. Come over, let's have some. Yeah, sure. What's your address? No. Paella means for her in the language she does it. I didn't know that. I had like Spanish lessons and I didn't know that. That's crazy. Etymology. Wait. Paella. From the old French. So it's actually my language. Wait, what? Which means pan. From the Latin words patella, which means a small pan or dish. That's not what it's not what it seems to be. Pan. Valencian language. Poêle. You have poêle. A poêle is a pan. How do you even... Une poêle? How do you even write that? I know it's like a poêle is a pan. So I guess it's pretty similar. I thought the Spanish invented it just like you. They invented me. What? But I think I understand. Finally. That makes sense. So if I have a constant force... Wait. On Earth, speed... Right! Because when I throw an item on Earth, it's going to be very fast, so it's going to be in a straight line. It's going to go in a straight line at first, but then it's going to fall because it's losing speed, because of the friction with air, right? But in space, if you just throw it in one direction, it's going to continue in that direction, isn't it? Is it? No, what I don't understand is why objects are moving towards Earth. So, how do you explain objects moving out of the orbit to go in space? Nothing naturally moves outward from Earth just because space-time is curved. It only does so if its initial velocity points along a geodesic that carries it away. What? Right. So initial velocity points. Yeah, sure. So suppose there's no gravity. Throw a rock, it just goes in a straight line. Oh, surprise. Now space-time, boom! Earth changes things. instead of one kind of straight line, there are many possible geodesics. Depending on your initial position and velocity, your geodesic might hit Earth, orbit Earth, escape, or fly past Earth once and never return. They're all equally straight in the geometric sense. Think about flying on a globe. If you start in Paris, well, okay, I understand. Escape velocity. Suppose you're on Earth, you fire a rocket upwards. Initially, you're forcing it with the engine. Yep, once the engine stops, gravity is no longer a force, in the GR description. The rocket simply follows the geodesic, corresponding to its position and its velocity. If that velocity is high enough, okay, above escape velocity, the geodesic doesn't loop back. It extends. Why do most objects fall back? Because their initial velocity selects a geodesic that intersects Earth. Imagine drawing straight lines on a sphere. Some wrap all the way around. Some pass through where you started. Some pass similarly in spacetime, while spacetime has many geodesics. Near Earth. Slow upward throw. Geodesic intersects Earth. So let's say you just throw something, then it's going to intersect. Orbital speed. Do I get it? Escape speed, only geodesic. I think I kind of get it. The way I picture this is big mass gets pulled by bigger mass. Yeah, but the problem with that is that you're thinking about Newton. But because big mass had a force applied to it after collisions to a size direction, it influences that velocity continuously, but never falling because of that collision. That's basically the way I picture it enough to make a game. Yeah, but that's like Newton. I don't want Newton. I'm trying to think about it in like general relativity. So like with space distortion. Because I have something similar to my game. And I'm thinking about how objects are going to leave the planets. And I want something realistic for that. Because right now, my donut has a space that's that tiles, you can say. Right? Like, let's go to my game. That's the actual reason. It's because right now, when I do this, I go in a straight line, right? This is a straight line. And the problem with that is, how am I supposed to go outside of the orbit if I just go in one direction? Right? That's my problem. How am I going to go up? By just going in a straight line with velocity. Because right now, no matter the velocity, I'm just looping around, right? But if you have enough velocity, you're supposed to be able to escape. Right? But like, theoretically, space is supposed to bend like it is in my game. So I just have a hard time understanding things. I think it's basically because I have like it's because I modelized this as a 2D thing. And then I loop. But if I take into account gravity... Drink, thanks. If I don't respond much, just know I fell asleep, okay? Yeah, woo, let's go, baby! I'm losing a lot of time on this. It's already 1 AM, oh my god. I did nothing. But I really wanna understand this. So... what is that? What is that? You mean the red thing? The Einstein stuff is for this game. Yeah, it is. It actually is. That's why I'm interested into how it works, because I have to understand how orbits work. So let's say I have a game with a sphere. Well, a game where I bend a straight line into a sphere, well, into a circle, we can say. So I'm gonna say in 2D, so it's like it understands more easily. So when I go in a straight line, I actually just rock around the circle. But no matter what speed I go in, I'm always looping around. What am I missing for it to be like general relativity? Is a devil coming after me or something? Loop around it. But, oh, what? The devil. Basically, these are the collisions. These are the colliders of my chunks. Like if I go there, I have collisions, right? I have my chunks in like 1 dimension, right? So like underground is like a full box of collision. Wait, is it going to... No, that's good. Is actually curving space, whereas general relativity is curving space-time. That's a crucial difference. Your system is essentially doing this. Take a flat world, bend it into a cylinder or circle, define straight as the geodesics on that surface. On a perfect circle, every geodesics loop around forever. There's simply nowhere else to go. Yeah, gravity is about space-time. It honestly looks like a statue from a perspective. Does it? I mean, I guess kind of, right? Ooh. Suppose your world is literally a circle, and then you can walk. Is a tangent? Well, it's tangent to the circle. You're right. Earth space-time is different. Instead, space-time is curved around Earth. Yeah. Imagine a huge family of possible geodesics. Some geodesics hit Earth, The geometry itself allows all of it. Missing dimension. When the world or perhaps 2D worlds wrapped into a sphere, Geo effectively has 3 space dimensions and 1 time dimension. The curvature lives in all 4 dimensions. That's what allows different trajectories. Wait, what if I represent it in 3 dimensions? Never mind, I get it. Why speed matters? In your world, geodesics depend only on position. Yep, I know. In GR, geodesics depend on position and 4 velocity. With the space, well, with time, right? Changing your velocity changes the geodesic. Imagine starting from the same point. So you have orbit, no. In your circular world, there is only loop, regardless of speed. Yeah, a game analog. Instead of bending the plane itself into a circle, define a function that changes how objects move. Yeah, that's why, well, near the planet, the straight line direction slowly rotates towards the planet. Okay. Far away, it barely changes. Yeah. Now, different initial velocities naturally produce collision, orbit, escape. Does it? Not really, right? Wait. Near the planet, the straight ahead slowly rotates towards the planet. Well, I mean, I understand what it's saying, but yeah. Transformation. Yeah, okay, basically the way it is bending around the planet depends on your speed. So I do need to check collisions. Oh no. I don't like that. But I mean, it's gonna be necessary. Transformation is something like this. Once transformed, every straight path on the line becomes the same closed path on the circle. It's more like changing the metric. I mean, basically, I'm not gonna be able to have real general relativity. That's a fact. Because if I have multiplayer, then I can't slow down one player unlike the other player's screen. I can't have real general relativity. That's a fact. I have to accept. So then I can basically only cheat with like what? With like how much I'm going down and up. More like changing the metric. Yeah, it is. Yeah. More like changing the metric, the way distances and straightness are measured, not just embedding the world into another shape. Yeah, I know. Intrinsic geometry. To literally bend the world into a torus or sphere, instead keep your world as a manifold with a position-dependent metric. Then compute... I think I was basically thinking of doing that. Then compute player... I'm just gonna finish reading. Compute player movement by integrating geodesics under that metric. Okay, maybe not. Maybe not integration. Well, technically it's an integration. But it's just like plus things, right? The world doesn't have one straight path around the planet. Wait. With a position-dependent metric. Huh. At every position, the local geometry tells you how your velocity changes. Different initial speeds and directions produce different geodesics. Some of those geodesics are closed orbits, while other escapes. in Schwarzschild spacetime. What? The metric, not a simple geometry wrapping, determines which geodesics are possible. Yeah. Okay. I'm gonna continue. My bad. I spent way too much time on this. Okay, so we have our Minecraft thing. Yeah, I really have to, because I can spend like an infinite amount of time looking at this, but at the end I need to make the game, right? So let's say we have this. Okay. Then that means... What does that mean, huh? That means in my collision Lauda, I'm gonna have some problems. So what are you trying to achieve? I mean, right now I just want collisions. Well, basically right now, collisions... So forget about the orbit. Right now, collisions work, but only on this side of the donut, right? Only like if I go there. But it's not gonna work on this side, because this is like 0, 0, 0, but this is -1, 0, 0. And it's not handling negative values, only positive ones, basically. And same here. So I'm trying to do that. The orbit stuff is like in the future. Like, it's not really about right now, but yeah, it's something I want at some point, I guess. Okay. So now to handle negative values, basically I'm changing the way I'm generating my chunks a little. And the only difference is that I'm going to change the connectivity graph and have like an abstract graph. So instead of like processed chunks, I guess I have to change this. So Dijkstra abstract chunk. Like this, maybe, I suppose. Here, I wonder why does each cube not hold a collision box instead when created? Performance. Performance. That's the reason. Performance. Because I'm planning for things to get a lot bigger too. So that's why I have like and I mean, we're talking about, well, different reasons. There are different reasons. The first one is performance, because if I want like giant objects, then it's not going to be fast enough. And the other reason is because the visuals you see are not where the objects actually are. They are just visuals, and they're bent. They're like, the position is changed in the shaders. So it's like on the GPU, and I can't have this on the CPU. I can't get this back on the CPU. And the collisions are on the CPU. So that means if I want to get this from the shader, it's actually another performance issue. So there's like actually multiple performance reasons, like a lot of them, that are not, that don't make it very possible. It's not practical. to have like one collision box for each cube. I mean, you can merge them. But well, I mean, yeah, that was talking about visuals. That's why I'm not handling the collisions in the visual space. I'm handling them in a straight, flat space. And yeah, because of that, they're not looping. I guess that's the reason. So, process chunks. I push back something. The start. But this is not good. This is a chunk, star, and this is an abstract chunk. So that's not good. I'm going to have well, I guess we have this dot chunk equal this, and then we have the span neighbors equal this dot get neighbors, right? Dot span. I was thinking about batching collisions when I was doing this. Yeah, I did batch collisions. I already did that, but yeah, basically it's just like a problem of loading collisions in my case. Wait, what's that? Oh, right. I forgot about this. I mean, I think I'm going to have to allocate. That's the only way. Because I want a vector of the neighbors, right, at some points. Right, that's basically a vector. Actually, I guess that's it. But if I just have this, that means we can't have like simple values like that, because the pointers are not going to be constant, right? So I need to use the how is it called? The thing. The allocator. How is it called? The page allocator. I guess it's not supposed to allocate a lot of memory because it's not like really big. But yeah. I still don't really like it. And there's basically there's a lot of things that are similar between the rendering and the collision graph. So that's why I'm not sure about that. How am I loading things right now? I'm loading the neighbor, right? And what? Because technically I could, well, technically since we only have cubes for now, we could like loop and have like generate the colliders in like a cube way, right? But if I'm doing that, it's because at the end, I want to curl the chunks that are getting, like the chunks underground, for example, the chunks that you can't access. That's why. For optimization. You want to generate 3D collisions, it's hard instead of 1D. Yeah, I already did that. I already have 3D collisions. The only problem is the generation. It's not a problem about what? It's not a problem of it being hard. Well, really? Well, or possible. It's a problem about it being... It's an architectural problem. It's about how can I make it the way I want it to be? What do I want, basically? Yeah, what do I want? Because I'm thinking about performance, but also I'm thinking about graphs, I'm thinking about a lot of stuff, right? I mean, I guess it's fine to have a graph. I mean, I already have a bunch of allocations, right? So just one is not going to change a lot of things. Well, just one, it's not just one, that's the problem. Maybe chunks don't actually have... Maybe chunks shouldn't have a neighbor in the first place. Maybe it's just colliders and visuals. No, because... No, because I have to sample the neighbors. Wait. Do I? No, I don't. Okay, maybe for advanced logic and processing, I will. But it's gonna be the same as visuals. And what about the colliders, though? I need a way to offset my colliders. Can I optimize the SAT? Let me look at this. So SAT collision algorithm. Let's say two objects share the same shape, but are at different positions in space. How can I... Well, can I optimize collisions with that fact? Technically, I can optimize the normals, for example, and the edges. Like, it's like the same kind. Same object. But then... Like, can I just share the same vertices? Immutable shared data, and the transform as per instance data. From simple to more advanced. Shares the local space vertices. I mean, yeah, I can definitely do that. Yeah, basically I have this, okay. Well, I don't have this yet, but that's the plan. Every instance references the same shape. Yeah, I know. So it's like a memory optimization, but not really a time optimization. Transform vertices on demand. I'm not sure about that. Instead of storing transform vertices, compute this. If the object is static, you can cache the transform vertices. Yeah, I know. Oh, actually, that makes dynamic objects a lot faster to update in this case. Well, not really faster because there's going to be zero operation anyways, right? We use face normals. Yeah, that's what I'm doing. Edge axes become cheaper. You can rotate the shared edge directions. Wait, what? You can rotate. You need to recompute edge vectors. Okay, so if all copies share the same edge directions, you can rotate. Yeah. Okay. Oh, I guess you have hash indeed. The same convex hull. Store all of this. One time. And you can basically cache, okay. I guess the cache is like a reason to do that. Biggest optimization. Transforms the axis instead of the vertices. Yeah, that's what I wanted to do. That's what I wanted to do. Suppose object A has this. Testing one SAT axis normally means all of that, right? Instead, you can, what is R and V and all of this? Rotation plus translation, right? So you can transform the position and then do the dot product on the axis with this. But instead, you can transform the axis one time. Wait, can you? Wait. Local axis equal the rotation. Oh, yeah, that makes sense. I get it. And then you dot. But that means the axis is going to be different, so you can't like cache the same way. You can't cache the projection. I mean, you couldn't anyways, I knew that. You don't need the plus. You just need to rotate the axis. But that's the only difference. Oh, well, I mean, actually, you just have to do that for one axis instead of like for every vertex. No, actually, if you think about it, yeah, it's good. Huge savings, yeah. But... okay, so yeah, this is actually the best optimization so far. So if we have... actually... wait, what? Wait, what? Oh, T. Wait, what? Wait, what? Uh... This plus T. Instead, local axis, and then projection. So you rotate the axis. What about the translation? I mean, the translation is a bit important though, right? Because, like, depending on the position, it can be colliding or not, right? I don't need more space. Relative transform. Oh, inverse. Ooh. I mean, okay. Now test S. Test against this. I mean, if it's the same object, right? I don't really want that. If the world is made of copies of one voxel. Hey, man! Have you thought much about modding accessibility? Alright, this is the new music. I haven't. Nope. I'm just cutting whatever I want. And I'm gonna make mini games on my game. And yeah, so nope. I haven't. But like, what do you mean by accessibility? Because right now I'm making basically a lot of engine features, right? I'm basically doing custom collisions, custom rendering, custom things, right? And accessibility is like for later. Like maybe you're going to have accessibility with like colors for like colorblind people. Maybe you're going to have, I actually don't really know, aside from that. But, well, blind people, more like Daltonians, right? But aside from that, I actually don't know much what there is, but I think it's like something to think about in the end, right? Like you don't want to create a game thinking about how you want everyone to play it. You want to make a game with the focus being a certain group of players, right? And then you might want to expand that group a little. Like I first need to have a game, and then I can add like accessibility. Like if you have specific examples, I would appreciate that a lot. But yeah, well, currently I have created a framework to live stream holograms of some games that allow modding, such as Garry's Mod. Oh, wait, what? To live stream holograms. Wait, that's not... Is it accessibility? Such as Garry's Mod. A framework to live stream holograms of some games that allow moddings. I don't really understand. What do you mean by holograms? What do you mean? When you say live stream, you mean like live stream on YouTube, or do you mean like live stream the game as like an hologram somewhere? And yeah, what do you mean? I don't even remember what I was talking about. Oh, this, right. So if you have this, if each block only stores this, you never duplicate vertex data. Overall, for identical convex shapes, I'd rank the optimization by impact. Yeah, so I was thinking about this optimization. Transform the axis instead of the vertices. Transform the axis instead of the vertices. What about the translation? Isn't that important? A local website you can visit on desktop, or more importantly VR and XR browsers. You can visit on a local website you can visit on desktop. Or more importantly, VR and XR browsers. Exporting player data points, okay. Okay, I understand that. And game map to my service, okay. Inputting that data in real time to a coffee table. Oh, okay. Oh, I see. Full 3D hologram of a live Gmod server. Yeah, you're talking about like a hologram in a virtual world. That's what I didn't really understand. Well, what I wasn't really understanding. Okay, so... Well, you can basically have a game... Well, yeah, you can basically have the... Like, you can basically see the game inside your game or application. Yeah, AR glasses hologram. Oh, and yeah, how would that help in accessibility? I don't really see the how the two fit together. It's like nice, right? But I don't really see how it's helping accessibility. And like, what does it? I mean, I guess it's the good thing is that it's a common interface to be able to visualize like maps in different games. I understand that. I don't know about it. Like, I don't know if I would need it. You don't need to apply it to every vertex. Wait. So it is. It is important. So you have this, for SAT, you project onto an axis. Wait. Matrix multiply, yeah. Let's go back there. For SAT, you project onto an axis A. Substitute the transform. Using the dot product identity. Right, will a modder be able to fully use your game models? How about exporting all data points of players in real time to a WebSocket? That would be possible. Wait, no, that wouldn't be possible. Well, it would be, but you're going to have a hard time. You won't be able to do that. Well, actually, well, no, you won't. Like, I could only make this hologram thing due to Garry's Mod being incredibly modder-friendly. Yeah. Basically, I have a problem in my game. And the problem is that my vertices are not on the CPU. They're on the GPU. So it's like very complicated. It's like very hard. To like send it to a WebSocket that should be on the CPU. That means I need to... I can't really... I mean, technically you can do it, but it's a pain. It's a pain. Optimized, baby. It's already optimized, that's why it's a pain. It's already optimized. That's why it's a pain. It's because I have everything on the GPU. That's the optimization. If I optimize things for you, then the game is just going to run at 2 FPS. Maybe not, but yeah, well, actually it's not that far off. Well, not if I retrieve it like every frame, but if it's like a screenshot, it could be fine. There's just going to be a big freeze. But yeah. Technically, you could reapply the transformation on CPU, but actually, wait. Okay, never mind. Okay, technically you can apply a transformation. No, never mind, technically you could. Okay, technically it shouldn't be that difficult because you don't need the transformation that the player has. Just researching possible games I might be able to build for. Got it. But yeah, no, things would look like really ugly too. Like, I think if you want me to have like basically my game and my models in, well, my world in your game, then that means in your game or like application, you would need custom transforms and you would need to modify things a lot in your own application. And that's a problem because it's relative to the camera. Basically, it's a transform of the vertex positions depends on the player's camera. That's the problem. So you would need to modify things on your side. I'm doing vertices transformations already with this Gmod prototype. Oh. What do you mean by transformation? Are you talking like about multiplying the, like changing the coordinates of each model from local space to world space? Because it's like a different kind of transformation I'm talking about. So that's why it's like a bit hard. I mean, technically I wouldn't be against, like if you want to spend some time doing that, I mean, go ahead. But it's just a bit complex, like more complex than other games, for sure. Because, like, really, because it's really weird. My game is weird. Because basically I have a donut. My game is donut shaped. And I have cubes. Right? I have cubes, this is a cube. But like with donuts, usually... Let's say this is a slice, okay? With donuts, if you want each cube to be on top of each other, then you're basically going to have something like this. Right? Where things just converge towards the middle. And then you have like cubes like this, right? But if you do that, basically the size of your cubes is going to change when you go down, right? And we don't want that. So we basically have some custom transformation that's applied to prevent that. So we always have cubes. And it's like impacting what you see, but it's also impacting the way you move the player, the camera. So that means you wouldn't have to modify like just the visuals on the GPU, but you would also have to modify the way you move the camera itself. So you can do it. Technically you can do it, but it would basically be remaking the renderer that I made for my game. Well, without... I mean, if you have collisions in your game, then... Nah, that's not really possible. Or like, basically you would need to re-implement your own pipeline, render pipeline, if you want to be able to select an object by clicking on it. That's what I did. So that's like a lot of work. That's a problem. And that's basically what I've been doing for like some time now. Okay, let's just finish this. So we have the chunk. Oh right, I was talking about this local vector and how we need a pointer towards abstract chunks. Abstract chunks, sorry. Well, my web application is Viewer only. Can I have indices instead? Technically, I should be able to have indices. Because... No, I need to store it somewhere. That's the problem. Well, my web application is viewer only, because I view/tabletop rendering of 3D games. Okay, I mean... if you don't mind having custom transformations based on the camera and custom movement, then technically you would be able to, I guess. But you would have to re-implement that on your own, like on your side. So it's like some work, right? But I already said that. So now let me think about... abstract chunk. I'm not sure about that. I mean, I guess technically we have two graphs for chunks. Do I really want a different graphs for collisions and the rendering? Maybe I want the same graph, but in some instances it's going to be different. And for those special cases, oh, that's a good idea. So I have this, and the one there is going to be this chunk, let's say. So for collisions, we want a new chunk. For rendering, we want to point to the same one as before, right? Oh, right, we want a new chunk, actually, in this case. So it's actually a bit more tricky than that. Yeah, it's actually a bit more tricky than that. Let me think about it another way, in a different way. If I'm rendering, then I just do a modulo. Well, basically, okay, by default, I have a set amount of chunks. Well, for this, right? In this case. So like this and this. So we have the next that is going to be null, right? Something like this. This is null. Now, maybe I can look up a hash map or something and do something depending on the context. Well, not really a hash map. That's a bit difficult. No, because I need like specific objects too. Okay. I'm just gonna ask. I need a connection graph for my chunks, but they're supposed to be a bit different because it's supposed to be looping for rendering, but connect to same chunks at different positions, like different positions for collisions, but with the same connectivity inside, with the same connectivity in, well, graph inside, well, among those chunks, kind of. What kind of architecture can I take? Can I reuse those graphs? Well, I can separate this much more cleanly than having two different graphs. Yeah. I really have three different concepts. Topological connectivity. Yeah. Rendering embedding. And physics yeah, completely. The first one is fundamental. Yep. Yep. The other two are just different ways of embedding that topology into a space. Yep. Topological. That makes sense. Notice there's no position. Yep, that's what I have. Well, right now. Then have different views. And that's basically what I have. Like chunk, no? For physics we have this. Both points to the same chunk. They are not different chunks, they are different render instances. Wait, what? Topological must instantiate several copies. Yeah, but that's not really the problem though. Infinite covering space. Yeah, but that I don't have my... That's not really what I want. Well, basically my problem, even the graph can be reused. Yeah, but... chunk repetition... I'm not sure about that. But what if I want pathfinding? With an embedded... with an embedding, let's say. Topological, no it's not. Embedded pathfinding. So your search node isn't just this, it's this. Embedding... +1. Technically that I could make it possible. Well, ID though, it's an ID. More generally, transform. Yeah, I know. We still don't duplicate the graphs. Instead, the search state is this. When expanding neighbors, do I want to... technically I don't want to duplicate the graphs, right? And I mean, if I have AI, am I going to duplicate graphs? What am I going to do? Well, no, never mind. Forget about that. No, never mind. Okay, I'm looping through the graph. Okay. Can that work? I might have an idea. I might have an idea. Let's remove this. Let's go back there. And we are going to remove this too. So let's say we have this. Okay, we have chunks. And same here, we're gonna have chunks. Okay. I get the neighbors. Okay. But the neighbors are actually not the neighbors I really want. Wait, does that mean I need a local copy or something? No. I need different kind of neighbors. How can I optimize? And technically just using a span might be good enough. Get neighbor chunks. And I might have different options, whether like I'm looping or not. And then get neighbor chunks. Okay, let me take a look at it. At this. So we have, let's say we have one graph, okay? Well, in chunk. Then what does that mean? You can, well, one graph with neighbors in chunk, okay? You can get those neighbors by coding get neighbors, right? What I wanted to do is you can, okay, so you have a function to get neighbors to get neighbors in a finite way. In the finite way, like there's a start and there's an end. There might be a start and an end. That's basically the graph, and how it is like by default, isn't it? Well, that's how it should be. Then you also have, you're also going to have a function to get neighbors in a looping way. References the one, well, the end references the start. And then you have this in a repeating way. So like after the end, you have a new start, right? But those ones are actually pretty similar. Those ones, the only difference is that you're going to have an index, for example, for those, maybe. So let me think about it. Is it going to be a position? Technically, it could be a position. But basically, neighbors, like chunks, are going to have like a position in this case. Maybe not chunks. Wait. But yeah, there's another identifier. There's like a repetition. I don't really like it. It feels like it's going to make it less flexible. And how can that take shape is the question. It's not even supposed to be a big graph. I don't really care about that. Well, actually, except for the rendering. And maybe for the AI. Oh, actually, okay. Never mind. Never mind. Okay, we might want that. I mean, technically, the graph could also just be an interface rather than returning vectors. So in that case, I mean, for cubes, it would be like very simple, right? But wait, it feels like it's wrong. Because if I call a virtual function every time, yeah, it's gonna modify what I... So virtual function plus getting hash map, getting neighbor is a hash map. I mean, it's not that bad, actually. It's not that bad. But then we can't have custom neighbors. But I mean, could I get that anyways in the first place? I mean, I guess technically you can still have custom neighbors. Never mind. Oh! I might have an idea. But I'm just not sure about the neighbors. No, the neighbors should be loud. Yeah, that should be fine. You should only load them like one time. So like if it's new chunk found, existing, yeah, you can skip the chunk, right? You can skip the loading of a chunk if it's like null too. So let's say you have the virtual function get neighbors. That's maybe for the best. Just on demand. Because I guess it's taking a bit of space too. But I don't really need it like all the time. I could cache that. So if I just go in the chunk and I go up, I mean, I guess the implementation depends on what I want. I guess it's an implementation detail. Wait, that's not what I want. Chunk. I have my neighbors. Yeah, but I do want to set my neighbors sometime. Actually, I'm not sure. I'm not sure anymore. I don't even know if they're like looping or something. I don't think they... I have no idea. I think it is looping right now. That chunk space. Let's go to cube chunk. I have no idea. Oh, no, it's not looping. No, never mind, it's not looping. No, never mind. Okay. Well, that's the problem. Is that it's not looping. And when I try to get the neighbors from the space, probably. Cube space. Neighbor. Find neighbor chunk. Then I have different things, right? But I'm not get chunk... This one is just doing a modulo. Wait, it's doing a modulo actually. Huh? Build chunk ID. Try add chunk from neighbor. Yeah. What even is out of that? Let me go back to my collision loader. So we have all of this. And when we load a new chunk, we try to add it from the neighbor. This is the thing. You know what? I've been thinking maybe I just want a graph. Instead of put the graph directly in the chunk. Maybe I just want a graph class that's a bit more abstract. That might, you know, take a bit more performance, you could say. But that's, you know, fine. Maybe that's just what I want. Maybe I should just do that. And Godot doesn't have a graph class, of course. I'm gonna make that. I'm gonna make a graph. Is it going to be templated? It doesn't have to be, it's just a chunk graph, right? But I'm going to need a graph for multiple other things. So I'm not sure. I don't think it has to be. What about my collisions? Do I need a graph for that? I mean, it's going to be custom, probably. Yeah, let's maybe just make a chunk graph or something like that. And that should be good enough. That should be good enough. And that way it's not there. Okay. Yeah, let's do that. That's actually the best thing I was thinking about. So core, I'm going to have something like copy and paste. And this is going to be chunk graph. Like this. And then we have Well, this is in core, right? So voxel core and voxel core. Here we go. Yep. Pragma once. Technically, I don't need to inherit anything in here. I can just do that and have a chunk graph, right? And then we can just include the chunky graph, technically. Okay, this is done. Just kidding. So we're going to have a nudge. So probably something like, do I want to forward declare it? Or maybe. Chunk graph nudge. So we're going to have a list of vector, a list of this pointer. So nodes. We are going to have well, this has a chunk, right? Maybe. We are going to have a hash map that goes from a chunk to the nudge. So chunk to nudge, right? So we can like actually go through the graph from a specific nudge. And what else? Yeah, we need a paged allocator. That's to do allocating nodes. Nodes allocator. We can include this for sure. So it's core, template, paged allocator. We have the local vector too. So core, templates, local vector. And I'm not sure about the chunk because I'm still not sure whether I want it to be on its own or not. Well, technically it should be a pointer there. We should have this. If we have the chunk. The question is, how am I going to build my graphs? And this is going to be answered in, well, after the break. Be right back. Okay, I'm just gonna get some water and I'll be right back. Okay, here we go. So. Boom. Well, let's keep the light. Here we go. Well, the music is probably fine, right? Okay, so we have the A hash map that we are still missing. Let me to include this. So A hash map, probably, like hash map, like this. I have no clue. It seems to be good. And now we have the chunk. Is that going to be a void star? Like a template? I have no idea. I mean, I guess maybe I don't need to put anything in there. Well, except like search algorithms. Yeah, it does good to have a graph actually. Graph.hh. No, third party, graph edit, graph node. Wait, graph node. This is like a node, so it's like, it contains a lot of additional things that I don't really want. Okay. Wait, does it actually? Is there like an inner, like a node inside? No, okay. So... Oh, hey! Wait, what? Nope. Okay, so is this going to... What is this? What is this? Is the actual question. Is that just going to be a pointer? No, we are going to have neighbors, right? So... Do we want a vector of neighbors for each node, or do we want it to be in page allocator? What am I talking about? I mean... What about abstractions of the amount of neighbors? Do I want a fixed amount of neighbors? If I have a fixed amount of neighbors, that means I can prevent allocations, which is great. Which is something I want. But might be a bit difficult. I mean, it's only for chunks though, right? Let me think. I think this is fine. I think this is fine. I can just template it for now. This is what I think. Because if I have like custom things, then it's gonna be custom. Yeah, that's what I think. So we are gonna have size t, like u in 32 nb neighbors. And we might also have the type. That's going to be type name, or like a class, I guess. A chunk. Oh, chunk. Type, like t. So then this is t. Wait. Going to do that. This is t. We are going to have an std array, or std array Godot C++. Do we have an equivalent? I mean, std array, I guess it's gonna be Godot core native way. Huh? Oh no. Let's have a std array. I suppose. From, well, t star to with the size. So no allocations. So that's great. Neighbors. And chunk. Do I want a constructor? Let's just set that to now. And I guess everything here should be set to null. Right? Maybe? Can I do that? I guess. So then I have all of this from chunk, I mean that's t to this. Object to nodes. Yeah, it's not chunk, it's actually just object, really. And yeah, we're gonna have a function. I might want to abstract this by with an inheritance. It's called type erasure. So we're gonna have something like t chunk graph node, and maybe we're gonna have chunk graph there, and we're going to inherit this public, and maybe we're gonna have the same with nodes. So chunk graph node, and it's gonna be inheriting here, right? Maybe. Maybe with a virtual descriptor, so we can like call virtual functions and stuff. But yeah. Okay, so let's say we have that. What if we want to connect? So let's replace this, okay? Let's go here. And we have Dijkstra right now, which is a bad name. For graph. Ooh. Let's remove this, okay. And now instead of Dijkstra, we are going to have the graph. Something like that. That's the face of someone skimming on their water intake. What do you mean? Do you want me to get more? I just filled it. I have a lot. Point to a chunk. And the amount is going to be... I actually have no idea. Actually, that shouldn't be here. Yes! Sure. You know what to do then. Let me actually remove this and go in the space. Let me go in the space. So here we're gonna have actually maybe I just want... Do I want a getter? Or do I want... I guess I want a getter. So I'm gonna have a... chunk graph. Gets chunk graph. Right? With like a class. Boo. And I guess it can be constant. Is it? Can it? I'm not sure about that. Let's just have this. Or like, I have no idea. Let's have this. This is virtual. And this is 0, maybe. So, okay. Good. Blah, blah, blah. Okay, got it. Here we go. Thanks. Cube chunk graph. Ah. Graph. Ah! Wait. Cube chunk. Oh, it's not graph, it's cube chunk space, my bad. Put a redeem of smacking yourself with a baguette or torturing French pastries. No! Not my pastries. I don't actually have a baguette right now, but I've been thinking about the baguette I ate yesterday for like so long. It was just the best baguette ever, man. Like, basically, because right now it's like summer and it's like really hot. It's like really hot. Like I usually do like some kind of soup and stuff, right? But it's like really hot. So I decided to stop. And instead, what I started doing is I tried making sandwiches. I know it's like I was gonna make a joke that was a bit you know. Anyways, anyway, so I decided to make sandwiches, and my god, it's just so good with like the baguette and like with what I added and stuff. I've been traumatized by sandwiches in college because I wanted to make sandwiches for school, like prepare them at home, and it didn't go well. I ate like a raisin one day, the small cookies type of pastries. A raisin? Wait, what? That's not a pastry? Oh, this thing. Got it. Yeah, okay. Yeah, I see. How was it? Did you like it? Un pain au raisin. Raisin is this, right? So I was like, huh? That's not like a pastry, but yeah, you have a lot of pastries that have like raisins on them. What a raisin. How do you call that in English? Grapes. Oh. Bro doesn't even know his culture. No, I mean, you don't say raisin, you say pain au raisin. That's why. We don't, well, yeah. Because you can like have raisin with a lot of things, right? Like you can have this, I guess. Whatever this is. But like, for example, you can have, I actually have no example. How do you call pastry in French? Pâtisserie, right. So yeah, you can have like a lot of things, right? With grapes, I mean, I guess. Like you have this, you have this, you have this, you have... I don't know. I mean, you have this a lot, though, but yeah. Okay. In fact, what in the water was that? What? That just jump scared me. What do you mean? Wait, what are you talking about? You know what? Let's close this, maybe. Oh, sorry, I didn't say that, did I? You don't get into the Japanese saunas. I don't, actually. I'm a bit too reserved, like private. You have to be subscribed to get me to an onsen. Maybe. I won't go. I'm joking. So what was I doing? yeah. We are gonna have not pastry. We're gonna have chunky graph. That's gonna be a graph. And this is gonna be B chunk space. Okay. Let's go here. Modules, voxels, core, chunk graph. And we're going to give like template arguments. So this is gonna be this. Opinion on onsens. I don't actually have one much. I mean, I've never been to one, so I can't really say. I'm just too private for that. I'm going to go there with an anime girl. An anime grill. An anime grill. I'm just imagining like I'm just thinking about Luffy, right? With like his meat. Like grilling, right? Just at an onsen. For some reason. Sun. Those look really nice. These anime grills. Yeah, maybe. So the amount of neighbors is gonna be 1, 2, 6. Here we go. Incomplete type. No, it's not incomplete. It's there. Right. Wait a second. Huh? No, it's there. My bad. Yep. Okay. So I guess I want to get a span. That means I need a virtual function anyways. Do I want a span? Well, do I want it to be a virtual function? I don't know. Anyway, so that should be good. And I mean, I'm gonna have multiple graphs, right? I'm gonna have a simple, well-paced graph. And I might have a loop graph, maybe. I don't know. I don't know about that. Let me think a little. Do I want to loop? Do I want it to be in the same graph? That's also a possibility, right? But I don't think I... Maybe I want like a hash map or something for that. Let me think a little. So do I want a hash map here for like loops? Like custom connections, and I can loop. Or actually, if I do that, I'm not going to have. Yeah, that's a problem. Okay, technically... I have no idea. I have no idea. I mean, if I just want a graph, I don't need this. Well, this is the data, right? But yeah. And I mean, I guess technically the data doesn't have to be a pointer, right? If it's not a pointer, then I can have the chunk. Like I can put a struct with the position and a reference to the chunk. That's a good idea. And then the hash map is going to have the data to... Wait, that's a good idea. That's a good idea. So instead of this, let's have data. From this to this. And that should be good. Now I go there. We are gonna have this. 1, 2, 3, 4, 5, 6. Good. Now we're gonna have... I mean, we could even inherit the graph, really. But maybe we have the base graph. Wait, do we want the connectivity? I'm actually not sure about that. Like extra connections, maybe? Well, extra connections. No. Ah! Like override? Oh, overrides. Oh! That's a nice thing. I low-key understand 0% of the thing he is doing, but I feel good around here. Good enough. I'm basically just making a graph. You know what a graph is, right? But the problem is that not that kind. A network. Well, I guess it's a network. You call that a network? Graph. Like this, like this, right? With my chunks. I want to connect my chunks. But the problem is that I want different kind of graphs. Like, for example, I have this. I have a chunk here. I have a chunk here. I have a chunk here. But then I have multiple possibilities. I have different kinds of graph I want depending on the context. Sometimes I just want those connections. Right? Sometimes I want to have extra connections going like this. And sometimes I want extra thing here. Something extra here. Holy stuff, I'll explode. No! Okay. But I guess in... Missing water. No, I guess the problem is that in the second case, that's the case I wasn't thinking about. In this case where I have more chunks, well, I have more chunks, right? Kind of. So I'm not sure about that. Well, I need another graph for that, I think. So yeah, I need this. And I don't actually want something extra. That's good. Okay, thank you a lot. You helped me a lot. Maybe. So we have the base graph. We have the... Drink, okay. Oh, Calvin, hello! Wait, Calvin? Who are you? Hello, welcome! Nice to see you! How are you doing? Loop graph. Loop. Then we have the repeat. Like the repeat. Wait. Repeat. Oh, C++, yay! C++. I'm basically remaking the whole engine. Good here. You? I'm good, I'm perfect. I actually finished my collisions today at the start of my stream. So I'm really happy about that. Can I show you the game? Do you want to see the game? Well, it's not really a game. I guess it's more like a proof of concept for now. But it's incredible, man. Sure, okay. So, do you know Minecraft? Well, yeah, okay, I'm gonna inside. I'm not gonna wait for you. You know Minecraft, right? Everyone knows. And you know how the world is flat, right? Well, flat. You know what I mean, right? It's like not a planet. It's like not circular, right? Like spherical. Well, in my case, actually, it's not flat. Are you doing a sphere? No, I'm not. So guess what I'm doing? Guess what I'm doing? A cube? No, I'm doing a donut. I have a donut. This is a donut. Oh, hey. And yeah, basically I managed to have some biomes there, as you can see. I have the grass biome, I have the snow biome, I have some rifts, you could say, like this. You know, I wanted to try having like some kind of underground things, I guess. It's like very basic, right? But I was basically just testing biomes and like the apes and like apes maps and that kind of stuff. And that warping looks so weird. Yeah, it does, I know. Because the warping is due to... You know, it's a donut, right? But it looks... We have cubes, right? The reason for... Well... Okay, one problem is that the interpolation right now is wrong with the warping. So that's like one of the reasons it looks weird. If you need textures, there's a Luanti texture pack called RPG16 that looks super good. I tried to look at texture packs, but they're all kind of It's not that I don't like them, it's about the copyright. Open source voxel game engine. Oh, right. I know about this, I think. Yeah, I've seen this. RPG16 is a Creative Commons pack. Yeah, I guess I didn't want to go for Creative Commons. I guess. RPG 16. CC by... So you have attribution. I mean, I could technically use it, it would just make me have to write this somewhere. But I could definitely use that. That means copyright won't get in the way. Yeah, I mean, it means attribution. I have to give attribution. That means like in my credits and stuff, I have to give attribution. And like if I make my game and I show it on stream, I'm not really sure how I can give proper attribution for streams, but like I guess people don't really care usually, but I mean, what? Yeah, I could use this because yeah, my cubes suck at the moment. I completely agree with you. I just use some noise to quickly generate something, but that's it. I mean, okay, I could use that. The grass. Well, actually, I would have to modify the textures a bit, I guess, for my game. But I use it in my game. Oh. You don't have to make a big display of it in every stream. Well, I mean, I'm opening my game every stream, right? So... so yeah. Let me just put that somewhere. Boo. Thanks for the recommendation. And yeah, I can place like cubes at the other face of the world. And I was, like, just to finish what I was saying, I basically have, not that. Wait, I can't open my taskbar. Okay. So yeah, well, actually it's this. So you know how, like, if you take a slice of a donut, it looks like this, right? And you know how every cube is on top of each other, right? So like you have this, and you have this kind of stuff, right? And then you have the cubes like this, right? But like basically yeah, they get smaller towards the center. Yeah, they get smaller towards the center, right? But I guess the distortion I'm making, I'm using is that when you go, okay, I have collisions there. I actually have to update them. But let's go here, for example. I don't have collisions there for now. So if you go down, you can see that cubes still have the same shape, right? You can see that here. And then when I get towards the center, it's just bedrock. And like if I try to go the other side, like I can just move just fine here. It's just good. Right? I still have the same speed and stuff. And if I try to go to the other side by going through the block, by going down 3, 2, 1, I go down and I still go down, but I'm actually going up the other side now. Just to prove that it's the center of the donut. Right? Like now I press up, I press the space bar, but I go the other way because I go up. So that's like one of the magics of the game so far. And yeah. I mean, that's been some work. One of the nice things with this is, well, it's a bit tricky. Well, it's a bit tricky because since I have some distortion, like to destroy a block, I can't just throw a raycast, right? Because it's like not the real position and stuff. So I actually have a custom raycast system, you could say, that makes me able to very, like without any performance issue, place blocks at the other side of the walls. Maybe you can't see them, but if we move over there very fast, then you can see that I actually placed a lot of blocks, right? I think what you said earlier about AI being trained on human data helped me. I'm forcing the AI to leave behind the human logic and use its full potential. Oh, its full potential. But yeah, and we have collisions, which is good. Custom collisions, right? Optimized for voxel walls. I actually have too many collisions I'm testing right now. Like colliders for all the chunks from where I came from to here have been generated. And like they're being tested all the time. So that's definitely something I should optimize, but as you can see, there's still no issue with that. I have no problem. So that's good. And yeah, I think with AI, if you treat it as a person, it's going to help you a lot better. For example, if you threaten it, then, it's going to act like a person. Like if you're kind with the AI too, right? Oh, I don't know. Or maybe if you say something like, you are a supercomputer, that's no, and give it some context. And roleplay. But yeah. Okay, let's finish what we were doing. What time is it? 2:40, okay. So we have different graphs. We have the loop. I guess that's fine. And we have the repeat. It tries to mimic human development processes, but my task is precisely about leaving that behind and going full fetch attack. Oh. So, loop graph. Let me think a bit about that. Loop graph. Sorry about that. Okay, so this one is going to loop, but it's supposed to be the same coordinates. Right, because it's modulo. And this one is supposed to repeat. So instead of this, we are going to have something like a pair. Let's actually have struct repeat graph T, maybe. We are going to have the value there, like chunk. Wait, it's not chunk space actually. It's chunk. We are going to have this, and we're also going to have the coordinates. So vector 3i, something like that. Yep. Can I have this inside, like an anonymous struct like this? No, you can't, right? Yeah, not allowed. Not too bad. Let me think. It's just a graph, so I don't need... Oh, actually I do need the... I do need to allocate in this case. Wait. It's supposed to be T though. Something like this. Then we have this. Then we have this. And that should be fine. Like, I guess I can just have, technically I can just have using node equals this. Boom. And now it's a lot easier, right? That's more understandable. Okay. Yeah, it should be good. So let's go. Let's go here. And now we have a bunch of problems. Good. Maybe not. BFS. So yeah, now... Well, the BFS has to... The algorithm has to work on... Has to work on the graph. So let's call it graph traversal, like graph traversal. Yeah, maybe. And it's going to be FS search this thing. And we might just copy this for now. Really? And state Well, it's just state like this. So we can skip, and now we have the start. So the start is actually going to be a node. Maybe like this. It's a node. We have this other node. Okay. And as long as I can get the neighbors, I don't need virtual functions. And I don't need the type. So should be good. Actually, do I want this here? I guess it's fine, yeah. Technically, I can optimize this, but what? But maybe not. Okay. Okay. Data enables. So we have all of this. Then we can copy this. Go here. We can remove this. And instead call it chunk traversal. Good. Process chunks. Right. Well, I'm not sure about the pointer, but okay. Hash set is not a template. You know what? It's time to include everything. Every templated thing is a time. It's time. So for this one, we want a chunk graph node with like basically we have like the node, we have the neighbors, and this one is it's supposed to be another node, well, an array of other nodes. And I guess instead of a local vector, it's supposed to be a span. That would be like the best thing. Okay, so this is a skip, that's fine. And then we have the most important one. That is this one. Oop. So node. This is, yep, this is this. We have the neighbor. We get the neighbor chunks. And we continue. And this is just fine. And yeah, we just need the neighbor chunks. And for that, instead of having a dynamic vector, like a dynamic array, that allocates on the stack and that's not very memory, like cache friendly, we can actually have, and I guess it's not really friendly, so it's a graph anyways, right? But instead we can have a span. So I could either make a virtual function that gives a span, or I could also make I could also make a span. So I can basically, like, usually when you use inheritance in C++, you want to use virtual functions and polymorphism, but you're actually not forced to. You're actually not forced to. Like, for example, in C#, it's like not a question. It's always, you know, kind of like automatically it's this way. But In C++ it's not. And you can basically save up a bit of memory because when you have polymorphism, you basically have a pointer behind the hood that is added to your instance, and that's like 8 bytes long, and like the virtual core is like costing some data too. But if I have a span, for example, in my node, I think this is still taking some space, right? Like a bit more, but enables span, for example. But yeah, it's like taking 8 more bytes than if it was polymorphic, but you don't have the virtual core difference. So like if you want to go through your graph, it might be better. But then again, you have like 8 more bytes. So like cache locality is, I'm not sure about that. I mean, if I have a fixed size, technically I can put the size there. And only have a pointer here. And it would be the same size as... Like each node would be the same size as if it was a polymorphic object. But the difference is that there would be no overhead to get the neighbors. So that's like a nice thing, I guess. Maybe I should do that. But for now, you know what? For now, I'm just not gonna care about that. Let's not optimize ahead of time. So we're gonna have... We're actually going to have this get neighbors. And it's going to be virtual. And that's it. Okay. I guess for now, for safety, I'm gonna do that, but well, no. Yep. Okay, so we have this. And this is gonna be 0. And I want to return the neighbors. Return. Actually, it's just, well, never mind. I need this. But this with neighbors dot. Huh, interesting. Wait, I actually don't have anything there. Maybe because I haven't included array. So let's include array. And now we have this .data in C++, in standard C++, it's not PTR like Godot. And then we have neighbors.size. Here we go. Okay, so we get the neighbors, and when we check... What's that? Oh. Huh? Graph traversal. Public. This. Okay, here we go. Okay, here we go, and now we have the neighbors, potentially. Chunk graph node has no... Well, get neighbors. Here we go. And this is no suitable conversion from chunk graph node. Oh, because it's, yeah, this. Wait. Okay. So then we have neighbors. And it's a const. Can I do that? This. Yeah, this is a spam. Const chunk graph node to const chunk graph node. What? What? I don't get it. Is it this? No, that should be good. Well, yeah. Const chunk graph node to const chunk graph node. Oh, star. Wait, what? That's huh? Wait, that's that's not how it's supposed to be. It's supposed to be like this, actually. It's a span of pointers. Because it's like an array of pointers. Yeah, you're killing it. Usually all those lines of code would kill me. I mean, thanks, I guess. There's going to be a lot more. Okay. So now we have the neighbors, we have this. This is good. Can I remove this now? I actually can. Ooh. And yeah, it looks great. That means we have like some algorithm that's nice. Wait, nodes. Bro, is this Godot? What theme add-on do you have? What theme add-on? I don't have any add-on. Oh, it's like the new Godot is like 4.7. If I have like a new theme, I guess, a new default theme. But yeah, but it's like not that kind of node. I'm making my own nodes. Like this is different because I'm making a graph. It's not the same kind of nodes, right? This is my node, custom node. And yeah, if you want to see the game, it's basically this. It's a Minecraft-like game. It's a voxel game where you have cubes that you can place and break, right? Where it's like generated, even though, I mean, there's still some things to do about that, about the generation. There's a custom render pipeline. I'm not using Godot's render pipeline. Custom collisions. I made the collisions myself. And when I say that, I mean I'm handling the collisions myself. And yeah, I would say that's it. When I dig down, we still have cubes, that kind of stuff. Cool, thanks. And right now, one of the problems is that collisions are only getting generated for like positions higher than 0, 0, but not negative positions. So I'm trying to fix that by cleaning the way my graph works, I guess. So I'm making like a custom class like this to have like my graph be separate from my nodes. And yeah, I guess that's it. I mean, yeah, technically it's supposed to be good now. So start, no. I actually don't even have the graph. Right. So. So what do I want? I guess what I want is I want to go back to the collision Laola. I have this. I'm going to replace this by... What's the problem? Has no member BFS. Well, it kind of does. Oh, actually, it's not. Yeah, it's this one. Okay, so instead we are gonna have observer data. I mean, it actually doesn't own the graph. So I'm going to have... Oh, that's going to be a bit tricky. Yeah, do I want this to be an information... to be information inside the graph? No, I don't want it to be. Do I? Do I want to keep this thing? Sorted chunk indices, not really. Well, I don't want everything. Wait, chunk extra, what is that? Next, no. I mean, technically I might want that though. That might not be bad. But I'm resetting it. Wow, okay. Let me think. Where do I want this to be? I guess I'm gonna have this in my collision loader, that's fine. So this is instead a chunk traversal. And we are going to include chunk graph, chunk graph traversal, I guess. So traversal. Wait, do I actually want this here? Because if I have different places... I'm not sure about that. I'm actually not sure about that. No, I think it's gonna be a bit different. Because if I want to reuse that, I guess it's best if I have it in the space. Chunk space. So we have this. Maybe we're gonna have chunk traversal. I mean, this one can be public, I guess. I mean, it depends which one though. And I have multiple... Okay, this is gonna be a problem. So we have all of this. Base, loop, and repeat. But I mean, I guess I can have something like this. Okay. And that means I have to implement this though. Wait a second. I haven't even implemented the get chunk graph. Oh, I don't have it. Oh no. So we're gonna have maybe Ew, that looks ugly. Maybe this. Yeah, I do want those functions to be like outside, probably even like if it's below the header file. But for now, let's just do this. We have override. We return chunk graph. So well, I mean, it's not going to be a pointer, actually. It's going to be a reference, isn't it? Is it? I suppose. Can I have it be const? Well, it's not supposed to be const. So let's have this. Well, this is supposed to be const, though. Can it be const? Is the question. Because I'm returning something from the... Yep. Yeah, that's what I was thinking. Okay. It's not identical. What? To not covariant with return type. Oh, because, okay, it's detecting a pointer, but I don't have a pointer anymore. So is it like a this problem? Like a problem because of this? It doesn't want to fix the problem. I guess it is now. Okay, it is. Let's say it is. So get base graph, like chunk graph. Then we have the get loop, well, looping chunk graph. And then we have the get repeating graph. Here we go. And I guess we want this in the parent. Okay, good. And those ones are working, so that's good. So it's in line, that's not really a problem, but okay. Well, that's good. So now when I'm here, instead of BFS, what I want is, yeah, the search, right? So technically, I might want... That's a lot of data, though. That's so much data. I guess... Well, yeah, it's some data. I might have something like... graph traversal, base graph traversal, and have this like for everything. I feel like my... Okay, that's when I'm thinking about having pointers instead, because I'm not sure whether like all graphs are going to be used or not. Well, it depends, right? And it feels like it's going to take some memory for sure. So like we have 12 bytes. This one has a lot of pointers actually. So actually that's fine if it's empty. It's 16, 20, 24 bytes. Oh, this one has 16, 20, 24, 28, 32, 36, 40, is it? I actually don't know about this one. It's a union, atomic, base, then well, it's a value, right? So a Boolean. I mean, if you... Okay, I guess, yeah, 40. With memory alignment and stuff, and padding. Well, just padding. Let me close this. So that should be alright still. Oh, I mean, I guess entities are not going to be like... Well, okay, maybe. Never mind. So we have the closest chunk, and we have the observer too, right? So we want different things from this. Let me think about this. Refresh chunks to explore. That's not really what I... So if I change the graph traversal, the place of the position of the graph traversal, maybe I should change this too. Or maybe I can have it on demand. Yeah, maybe I can just have it on demand. Yeah, I mean, yeah, okay. So BFS doesn't exist, and let's have graph traversal, graph traversal equal. Can I get the space? 2 space. Then we have traversal. Wait, what? I have that. Oh, interesting. Oh, I don't have functions for that. To get the graph traversals. So let me make them. To traversal. Is it good now? Cannot be initialized. Well. Graph traversal. Here we go. And now we just have to put this in the parent. So like here, we have this with 222, and this is, I guess this is a class. Yep. But I'm going to forward declare here. And we have references, of course, and it's virtual. Yeah. Oh. References, here we go. Okay, so now it's good. So now I can get the what do I want in my case? Collisions. So I mean, actually it depends. It actually depends. Because once millions of players each paying $5 to $10. Yeah, I don't know what the context is, but that would be nice. Yeah, for sure. But also, you asked, what do I want in my game? Oh! No, I don't want it in my game, I want it in real life, okay? That's different. No. Well, I mean... Yeah, I mean, play... Yes! How should I handle collisions? Because if it's looping... I mean, actually, let me just get the space. space. Boom. Here we go. Can it be initialized? Huh? Can it not? Craft traversal. Oh, yeah, it's the traversal. But what? Get space? Yeah, I actually have some problem with that. No, I don't have a problem. I have the... I was supposed to have an enum somewhere. Cube chunk space. Is it about... Oh, that's it. Oh! T'étais pas français, tu faisais du Among Us. Je suis toujours dans ton serveur Discord. Oh, Nifox! Oh! I see, I see. That's nice. I appreciate that. Merci. J'apprécie. J'espère qu'on va pouvoir faire du... Ok, l'un de mes plans... Sorry, I'm speaking in French a little, but bear with it like for 30 seconds. L'un des trucs que je veux faire, c'est que je vais avoir des parties d'Among Us dans mon jeu, Voxel. So let's play this when it's done. Pas de problème, je suis canadien. Ok. Ouais, mec, les souvenirs. Ouais. Oh oui, mec. C'était incroyable. It was really fun. I liked it a lot. That was really a fun time. Well, there was like a lot of people that didn't. Well, there were like some moments, I guess, but it was like very nice overall. Well, the cool kids say, je suis Canadien, I'm here. Am I right? Je suis Canadien, am I right? I thought to stop posting and streaming. No, I actually just switched to English. I actually want to make some new videos, but I've been... Like, my monetization have been removed from my French YouTube channel. So instead I have an English one. Where I live a lot, where I stream a lot, right? And I play jam games, and I do a lot of programming. And right now I'm making this game. That is like Minecraft, but it's a donut for now. Right. I mean, I think you've been here earlier, right? Or was that you? Oh no, it wasn't you. Why don't you stream on TikTok? Technically I could. I guess I knew you could stream on TikTok, but yeah. I don't have it. I don't even know if I have a TikTok. Maybe I should look into it. Because I'm already multi-streaming on like Twitch, YouTube, Kick. So I could definitely do that. But yeah, I guess so. I don't know at all about the community over there. Like, for example, on Kick, I actually have 41 followers on Kick. What the fuck? Basically, I just never look at the comments over there. And for some reason, it seems like some people just follow me. So maybe I should just do that. I don't know. Huh? Wait, yesterday a bunch of people followed me. Like 5 people. 6? 7? Oh, no, I did it. But yeah, that's it. I haven't done it. 6, 7. I mean, we talked about TikTok, right? So that's fitting. I advise you to start streaming on TikTok to get popular faster on it, so you can build a community. Oh, I mean, you're right about TikTok and faster and stuff. I don't actually know. I don't even know how to look at live streams on TikTok. So I'm definitely going to think about it. And if I stop procrastinating, I might implement that idea. So I appreciate a lot. To do stream on TikTok. Got it. Thank you a lot. I appreciate. Do you... Basically, I was thinking TikTok was like this kind of super active kind of platform where everyone is just kind of crazy, I guess. But yeah. And like I was thinking live streams were very dynamic. But like, is it fine? Like programming? Like, is there like some programming content on TikTok? Well, I mean, I guess short form videos, I guess, right, of programming, but live streams, I really don't know. Non, sérieusement, à l'époque de Among Us et le serveur Discord, c'était vraiment incroyable. Oui, yeah, it was incredible. Let's have this again, one of those days. Maybe I should just like start a French live stream. And, you know, on my previous YouTube channel. Well, my French YouTube channel, because I still want to make videos on that. But yeah, basically on my French channel, I want to make videos. And probably I'm going to put the same videos on my English channel. But, you know, translated, right? I want to translate, and I want to make nice and clean videos, but I need a game first, a good game first. But how it was possible that the server fell off because we were so many? I mean, I guess Among Us kind of fell down a little. And yeah, I think it's Among Us in general. Like nowadays, it's like kind of a lot harder to see like to find community discords with people that play Among Us, right? I think it's like the hype fell off. That's like one of the reasons I changed my content. And yeah, I would say that's it. That happens. You know, it happens with games, right? So I could have potentially continued the hype by switching to another game, like a recent game that was popular, and, you know, do like the kind of thing gamer streamers do, right? Like gaming streamers do. But I wanted to continue my... Basically, I wanted to make games, right? I'm a programmer, really. I'm a game programmer. So I wanna make something rather than just play. Because, yeah, I feel like if I play like all the time, it feels like I'm a bit losing my time. So I want to, like, for example, this week, I've been streaming for like 46 hours. And if I spent all of that doing some gaming, then, you know, like with only like maybe 5 followers, then I would have felt like all of this. I would have felt like all of this was just kind of like for nothing. But since I'm like creating something in the meantime, it's like, you know, I really want to create something. I guess creating the game comes first. And, you know, like streaming helps me with motivation and stuff. I'm not sure, but in the server, some of us started playing Minecraft. Oh, yeah, we did play Minecraft. But I mean, I guess I did create like, you know, I did have servers and stuff, right? But I guess the servers kind of fail. And I mean, you have to, it's not something you can just keep in the background. It's something like that you have to check regularly, and you have to pay for the server too, right? You have to, you need like moderation, you need, it's like, right? What do you use, JavaScript or Python? Neither. I use neither. Like Python was just for my French channel. I actually don't even use it that much. I don't really use JavaScript either. I use, I mean, I guess I have a bit of GDScript in this game because, you know, to script things. But all of this is C++. It's C++. That's actually one of the reasons too I switched to English. It's because, like in French, like basically all the programmers that can code in C++ that are French can also speak English to some degree. So if I stream in English, I'm going to keep that possibility. Well, I'm going to keep that audience, but at the same time, I still have the English audience and like the international audience. So that's why I stream in English, and I switched to another YouTube channel because I wanted to do more programming, and the people that want that, or you know, I'm going to have a bigger audience if I stream. Well, if I have it in English. Well, a bigger potential audience. But I should make some videos, but I'm just procrastinating. I just don't like editing a lot. But I'd love to share like my knowledge. Like if you want to know things about game development, I made a Google Drive with, for example, with puzzle games. You can see different game design concepts that you can use to make a really nice game. Right? It's like the same with like marketing and game jams and stuff. I just have to convert those documents into videos, and maybe I'm going to translate them in French too, and you know, post that on my YouTube channel. That's like an idea. Like my marketing document is like 16 pages long, right? Just a lot. So yeah. So we have the traversal. I'm going to read that. And what? In a nutshell. Boom. Protest chunks. Oh, no, I don't want that. Wait, what? Chunks to spawn from. Huh. Yeah, that's not really what I want. I want, I mean, I guess this should be, this thing should be in the traversal. So this one is last node processed. Boom. Chunks to spawn from. It's more like nodes. I don't actually know what to do with this. Oh wait, that's yeah, that's process chunks, right? So this is actually just this. It's not actually, well, okay, it is sorted in that order. Okay. So I'm gonna clear. Hash set. Yeah, that should be fine. So wait. Chunk graph. Right. So I can just do this. Boom. I mean, if you have any question, feel free. I'm always here. So with that, I don't need this. Now, traversal. It's not the base traversal, though. It's going to be... Well, for collisions, it's repeating. So then we read that. I don't need this anymore. Chunks to spawn from, yeah. I can set the start. And process chunks push back the start. Like this. What's the problem here? Oh, right, I need the... Oh, wait, that's actually good. Wait, is it? Well. Well. I have to get the right chunk. That's the only problem. Get current chunk. Yeah, this one is a problem. And this is a dot. Yeah, I'm not sure about this one. But basically, most of it should be solved by doing this. And then we have last chunk processed. Okay, this one is fine. No, it's not. This last node processed. And this is a chunk graph node instead. We have this. And inside we should have... What should we have inside? Oh, just the data, right? So like... not that... Oh, I actually don't even have the data here. Oh yeah, because I'm abstracting this. Well, with the nudge, I don't have the data. So. Can I get the node in a safe way? I mean, technically, maybe I can, even though I erase the amount of neighbors, I could... Do I want a template? Get data, span. Let me think. Maybe that's I'm not sure about that. I guess I just want a chunk in the end, but how do I get this chunk? Can I just convert it? So wait, let's say we have this, we have the chunk, and we need to put it in here. Try add the chunk neighbor. Maybe I want to put the nodes directly instead. What about that, huh? And that way... Yeah, that should be nice. And the neighbor index. Yeah, all of this sucks. But I don't want to have like too many modifications all of a sudden. I don't want the rendering to suddenly break because I'm modifying the collisions. So I'm going to go at it slowly. Okay. Right now I have chunk space. I'm going to duplicate this, and in the end I'm going to make this obsolete. But for now I'm just going to duplicate it. So I'm going to put this here, the from. And I actually don't know what this, where this node is from. I mean, technically, if I still want my graph to be good, let's say, I could call a function from the space to take the chunk from that, like space. Oh, I have a problem here too. Oh yeah, that's normal. Let's change that. Is graph traversal? Okay, good. And now we have space gets chunk from nodes, maybe? From graph, maybe? From graph node. So we have this, and I mean, one of the problems is that the type might be different, right? So this is from chunk graph. Gets repeating chunk graph nodes, maybe? Well, chunk. Something like that. Maybe something like that. So I guess this is going to be once again virtual. So many virtual functions. So we have this, we have the chunk, we get. It's not supposed to modify anything. Okay. And now we go here. I mean, I guess technically Well, okay, repeating is like an exception, never mind. So we have this, we have an override. And we need the node. We need the node. Where's the node? Oh, undefined. Wait, is it? No, it's not. Huh? This. And I'm going to cast it down, I guess. Static cast. To this. Like, I guess we can have text type this nodes. That's nice. That way it's going to update automatically. I don't have to change it. And I cast it from one to the other. And the node is what? Is it a pointer? No, it's not a pointer. So something like this. Okay, good. And after we have that, what? Wait. I mean, I guess it's just this, right? I just want to get the value. So this dot data. So I can have a reference, for example. Can I? Data. And I can just return data.chunk. That's it. That's all. Pretty simple. Repeating chunk graph chunk. Wow. Yeah, the name sucks, but that's fine. So we have the chunk. We can put it there and everyone is happy. Everyone is happy and this is good. So then we have a dot size instead. And yeah, we might actually have this traversal somewhere else. But let's have it here for now, I guess. Maybe not. Resize. Yeah, this one is gonna be using the traversal too. So we have like this dot processed chunks, like that. Okay. Yeah. Then I do this. Same thing, right? Yep. I have the indices and everything is good. Maybe. Do I actually want the indices? Or do I want a new array? I'm actually not sure. Let's have this for now. Okay, so we have all of this. We need the first chunk. We need has no member chunks to spawn from. Well, yeah. We're gonna get the space. Well. Observer. Get space. And then we have... right. I'm not sure about that. Definitely. But that should be fine for now. So let's say we have this. Oh, wait, never mind. Oh, no, wait, this will be different. We need to get... observer data. Oh, it's a traversal. Graph traversal. Traversal equals space get traversal, repeating. And now we want this. And processed chunks like this, maybe. Cannot be used to initialize an entity of type chunk. Right. Get chunk. Here we go. The chunk. That's a lot, oh my god. I don't really like that, but that should be fine. That should be fine. We compare and exchange, and we load, basically. Yeah, the only problem is this. I actually have no idea for this. Technically... Technically what? I have no idea. I also don't like how collisions are not going to be abstract anymore if I continue this way. But well... Yeah, I'm not sure. A value of type chunk cannot be assigned to an entity of type chunk graph node. This is a problem. I have no idea on how to solve this. What time is it? 4 a.m. I mean, Rudast chunk. It's like specific to the collision. It's not really the current chunk. What is it? Oh, actually. Oh! Actually, I might have a way. Do I? Yeah. Yeah, let's actually change this into collision chunk. Well, collision node. Gets chunk collision node. Maybe. And this is gonna be a chunk graph node. That's just a node, really. And we're going to have the cube space observer. Let me just take a look at this. So I do have something here. I do have this. So that can come in handy. But I can also just have this here. I can have graph node equal now. Like collision chunk, maybe? Kind of. You can say. Then I can just set it. Should be good. And I'm just gonna add this here, I suppose. Wait, I have a get, I have a set. But there's no... Oh no, never mind. I do have this. Oh. We have the get and observer. Wait, this is a signal. Yeah, I don't have any property about this. I mean, I don't think I really need it, but... Oh, never mind. It's not even it's not even an object, so I can't really show it anyways. Right, I can't reflect it. So, I mean, I guess I can't actually do this. That's fine. I don't mind. I'm just gonna forward it then. I guess everything is just going to be our ID, potentially at one point. Cannot be assigned to an entity of type this. Mm-hmm. Mm-hmm. Chunk. Undefined. Yep. And this is good this way. Yep, this is good this way. So I have all of this. I cube chunk space, where is it? There. Cube chunk observer. I'm gonna have collision SIM cards. Am I actually updating this? On new chunk. Oh. Wait, what's that? Am I actually using this? I am actually not using this. Actually, maybe in GDScript. Oh, I think I am. So in this case, so in this case, I might... Yeah, it's like tied to a space, right? So I might just get the collision chunk. Go here. And... New chunk, nah. And when we have a new chunk, wait. So we have the coordinates. Oh, so we have the coordinates. Oh, this is crazy. Huh? Oh, right, that's fine. So just before this, I want to... Right. Cube chunk. Yeah, so cube chunk base. Repeat graph. I mean, technically, right? Well, this is a node. So I can have the well, collision graph. Like repeating graph, I guess. Wait, do I want this? No, that's not what I want. Repeat graph. Well, you know what I'm going to have using this everywhere? Do I have the cube chunk space here? Yeah, I do. Okay, perfect. So I'm gonna have something like public, I guess, using base graph. Well, T base graph, I guess. Then I'm gonna have the same for this. Wow. Yo, he's not neon white anymore. I guess. Are you sure? Are you sure? Look at this! Right, okay, so that's here. Ah! How are you? How are you doing? Undefined. Right. Right. So I guess I'm gonna have this here. And then I'm gonna use those. So here. Well. Looping graph. Then we have the repeating graph. Repeating graph. And we also have the nodes, right? I mean, I guess I can just use this actually. So let's say I have cube, chunk, space, graph, like a repeating. Like, actually, is it repeating? I guess it is. The repeating graph. Node. Pretty bad. Oh no! I mean, I had a really good day, but a couple hours ago I saw your face and it was very... Well, no. But a couple of hours ago, started to be extremely sad for for literally no reason. Stupid brain can't produce infinite dopamine without suppressing sensitivity to it. Oh no. I mean, I guess that happens. Your brain is either very powerful or are used to the material enough not to faint. From Hyundai. But I mean, yeah, when I'm feeling down myself, I guess I just stop thinking and I just do something, right? Like do an activity like programming, for example. You can like start a stream and you can code a game. And no, I guess actually sometimes I still do think about other things, but I mean, you know, when you're happy the whole day, in the evening you're just exhausted. Yeah, okay, that kind of yeah, I mean, in that case I would just go sleep, honestly. I know what you're talking about. I guess it like happens for a lot of people. Like basically like in the evenings, it's like the time where people get depressed, I guess. I feel like I had a very... Well, I guess I've discovered it in like high school and stuff. But yeah, and in that case, like when I feel down, well, if it's like because of sleep, I guess I would just go sleep. Hell nah, tomorrow is Monday. No way I'm going to sleep to skip time to get to work again. Just think about it in a different way. If you go to sleep, you're basically teleporting yourself to breakfast. Do you want to breakfast? I mean, the thing is, whether you go sleep now or like a bit later, you're going to sleep the same amount of time, right? So, you know, you might as well wake up at like 5 a.m. Like sleep well and wake up at 5 a.m. and do what you want. And then I don't know. Maybe, okay, maybe that's not the best idea. But I mean, I guess I've been streaming a lot, right, recently. So I had like moments where I've gone to sleep at like 5 a.m. because of streaming. Well, I say because of streaming, but just because I just really wanted to finish something, right? And yeah, work was difficult. Well, actually, wait a second. No, I was talking about going to sleep earlier. Well, okay, there's a weekend. No, there's a week where I was on holidays, where I ended up going to sleep like more and more late, and I ended up gaining a whole day by just pushing more and more. And then I ended up going to sleep very early, and it was a bit difficult for work because of that. Breakfast and 12th the new work week. More papers, more deadlines, nah. Oh no. Well, think about it another way. When you go to sleep, you're just good, and then you let all the future things to your future self, right? It's not gonna be you, it's gonna be your future self. And he's gonna deal with it. He's gonna deal with it. Right? It's like what I do with programming. Sometimes I just don't want to spend time doing stuff that I don't like, so I just don't do it. And then my future self is going to have to deal with it. And sometimes my future self is just hating myself, my past self. Is this why you don't sleep? Like looping? I mean, I guess I just don't sleep much now. What's your job, by the way? Okay, that's gonna be crazy, but I'm a game engine programmer. I know, that's crazy. I'm a game engine programmer, and I've just spent 37 hours this week streaming game engine programming. So on top of my 40 hours a week of engine programming, I do another 37 hours of engine programming. What an unexpected turn, right? That's why I'm not bad at it. Because that's like literally my job. So, yeah. I mean, are you allowed to stream the source code? Like, isn't it violating the NDA? That's not it. I'm not streaming the source code. This is my own game. I'm not allowed to... Of course, I'm not allowed to stream their source code, like the source code of the company, but this is my game. This is not the game of a company or anything. This is mine. And like I do have a lot of NDAs about like projects I'm working on and that kind of stuff. But yeah. I'm just having fun. You must be immune to melatonin. Is that the thing that makes you like sleep? Oh, right. I mean, I do have this though, but actually no. It depends, but I can fall to sleep pretty easily because maybe it's because I don't sleep, so when I like sleep, I can sleep easily. But yeah, I guess I don't really have a big problem with that. Well, I mean, it depends. I do get tired pretty easily during the day sometimes. Like if I well, I guess I don't really have this problem right now. But if I go to sleep pretty early, then the day is difficult. I just don't feel sleep when I'm streaming. Well, I don't feel myself being like lacking sleep when I'm streaming. Well, it depends. When I start stuttering a lot, I guess it's like different. But like streaming helps me. It helps me. I don't know. I think my brain is just overloaded, and I just don't think about it. Sleep? What is that? I just don't know that. Okay, I just get some sun. Lol. Yeah, I mean, yeah. I mean, I did go... well, I did go jogging actually a bit earlier, so... Kinda like the survivors in L4D, or immune to the virus, or The Last of Us, how Ellie is immune. Oh, that's a spoiler, I haven't seen that. Or something for, like The Cure, yeah. Collision chunk. What even is that? Oh, never mind. That's gains the parent. So I have the node. Yeah, I have to find the node. Well, actually, let me go there. Okay. So huh? I want to assign it. And what? I guess cube space finds chunk. I mean, actually, let me think about it. I actually don't know. I have my data, but since you're working on the engine, I do have a question. I want to build the PSX War Thunder in C++ with Raylib. So should I just build my shaders F# plus Raylib? Wait, F#? Or C? No, F#. I'm not familiar with F#. For PSX style graphics, I'll rebuild the Raylib to my liking, which will improve current results, but take like whole another year. Basically, I don't have an engine. I mean, I guess maybe I can tell you what I'm doing right now. Basically, I started with Godot because I think it's important to have an engine. But if you want to, if like there's something you don't like with the engine, then just remake it. Like for example, I remade the whole render pipeline. I remade the collisions, and I'm probably going to remake the animations, like the skeletal animations and that kind of stuff. But yeah, I would say that's it because I value time. I think it depends on what you want. Do you want to learn or do you want to produce something? What is your goal? F# is basically C/C# for math. Wait, that's very different. But okay, I got it. And PSX War Thunder. I mean, I don't know War Thunder, but PSX style graphics, right? Oh, PlayStation. Okay. I mean, if you don't use an engine, I guess the goal is to learn. Right? Or like, is there a reason you're not using an engine? Should I... Wait, the question was, should I just build my shaders? F# plus Raylib? What... For PSX style graphics? Or rebuild the Raylib to my liking? I don't really understand your question in the first place. I mean, I have pure C++, which is my engine. Yeah. Raylib, just a render lib. Yeah, I know Raylib. I guess I don't really understand your question about build your shaders with F# and Raylib versus rebuild the Raylib to your liking. No engine because I hate engines. I want to be free. The question was, do I just use Raylib with custom shaders? Or is it better to rebuild rendering myself? Oh, I mean, I could send you the results I have right now with the shaders, but something feels wrong. I mean, if it's just rendering, I basically made my own render pipeline, right? So it's not that complicated. Well, if you know how it works. If you don't, then you can learn, which is nice. But relive with custom shaders. Let me just look at how it works. What is it using? Ew! Ew! For the objects, uses a built-in virtual camera. Begin mode 3D. Wait, is that... It's OpenGL, that's what I was thinking. Basically, the begin and the end are like functions that you use in OpenGL like before 3.3. And it's like, it's been replaced after 3.3 because, well, basically in OpenGL you have modern OpenGL and you have the old OpenGL. And this is from the old OpenGL. So I definitely don't like that. I mean, I would re-implement my own. I mean, well, I don't really see the point. Well, if it was me, I don't really see the point in using Raylib a lot. I would just like have GLFW. Like, it's like the minimum to have your windows. Basically, like your window. And GLFW, IMGUI, immediate GUI, basically for like UI. What else would I have? Maybe something like physics for collisions, but I'm remaking my own, I guess. So I wouldn't need that if I was making this game. I've got no idea how it works yet. I just need PSX, so I don't think I need new OpenGL. It's not like I'm going to make hyper-realistic stuff. I guess so. I mean, if you want something like really advanced, you know, you have like Vulkan. So it's not as if modern OpenGL was like that advanced. It's just that it's a normal way of doing things. I would say I would call it this way, but basically, from what I remember, the old OpenGL. Let me get an example. But basically, I think it's like every frame. Yeah, every frame, you have the begin drawing and the end mod 3D, right? Well, and the end draw, right? It's like every frame. That's like crazy, isn't it? And that's why usually... Well, basically modern OpenGL is just you use buffers and you just bind the buffers and you just push them. So you don't have to send all of your data. So it's like a big thing, really. Well, I really recommend. Well, I mean, if this is like Raylib, oh my god. Okay, so personally I wouldn't use it, but I mean, we're talking about you, right? So if you want to, if you're interested, you don't know how it works, right? But if you want to know how it works, you can just go on this website. It's a very great website. And you have like some very easy introduction with like creating a shadow, a window, I guess, okay. You have Hello Triangle, where you have like a triangle, And this is basically what you're going to do with Raylib, right? So basically, after this page, you're going to be able to have your triangles. Isn't every engine render everything every frame? No, well, basically there's a difference. I'm talking about CPU to GPU. I'm gonna show you what I wrote, for example. I have a custom render pipeline where I have a draw. So basically every frame I do this. I call my objects, and then what I do is I begin the draw. I bind my render pipeline. I bind. You don't have that in OpenGL. You don't have all of this. You just have a shader, I think. So you don't have to worry about too many things. But I bind my render pipeline. I bind my uniform set. And then I draw a pack, which is basically me just binding my uniform set and stuff. And what I'm doing is that ahead of time, I have my, let's call this GPU and CPU, okay? We have the CPU, right? This is what is running the game normally, and the GPU is the one taking care of like the graphics. With modern OpenGL of what I'm doing, you basically put your model ahead of time here, right? So you have a very big copy from the CPU to the GPU, where you push your model data there, you push your vertices there, right? And then every frame, you just send some little packets that are basically just indices that point towards that data. Okay? That's modern OpenGL and like Vulkan and stuff. But with like Raylib, as you can see, the difference is that every frame you put your vertices. Those are vertices. And basically all of that big data, those big vertices, what you do is every frame, you have this, and you copy it to the GPU. And that means you're going to have some delay because of synchronization and that kind of stuff. I mean, if I were to have 60 to 120 models loaded every frame at 50k to 120k trees a scene, will the PC die because of Raylib's rendering? That's possible. I mean, basically, I don't think Raylib has its own culling, so Raylib 3D does its frustum cull. Or maybe, wait, it does have a camera actually. It does not do frustum culling. So yeah, it will die. It will die. Probably. I mean, for the whole scene, isn't really much, is it? It's a lot when you push the data from the CPU to the GPU, which is not what all games nowadays are doing. Well, I mean, by dying, let me actually just ask a question. Sending to vertices from CPU to GPU, because you don't just want the vertices, right? You want to push the UVs too, because you want textures on your models, right? Every frame. How much time? This. Wait, milliseconds. a modern CPU and na. But then you have the UVs, right? So... Well, it's actually pretty small. Every frame. So let's change the question. Let's say your vertex is... Let's say you have 3 floats. That's like 12 bytes. Plus your UVs that are like float plus floats. So that's going to be like 20 bytes. And you do 20 times this. So that's like... It's actually 2 megabytes. Wait, times 32. Wait, did I... Wait, 32. Wait, that's crazy though. And I guess textures have to be... Well, actually I'm not sure about textures. But no, you don't have... Wait. So... Millisecond. Boom. I mean, just that is fine. But then you have the first time culling. Okay. Never mind. ChatGPT says that no, Raylib sends the whole model to the GPU on first load, and only then it updates it with small packets. Raylib usually does this: load model, create GPU vertex buffers, upload every frame. Wait. Draw model every frame. Yeah, so it's basically saying that it's like the optimized thing. I mean, you can say that, but even if it's the case, you still have those points, right? Okay, so my project will live. I guess it can. I mean, in any case, I guess... Yeah, it does no draw cube. But, oh, wait, is that a function from Raylib? Wait, but that's... Anyways, I mean, it seems like... I think you can use it. I think you can use Raylib. It doesn't seem like that hard to have something like some base rendering, right? So you can like start with it if you want, and if you have like some performance issue, you can switch. But yeah, that's Raylib's function. So no STD. Yeah, I got it. I thought it was like a function that ChatGPT, well, it's not ChatGPT, but that the AI created, right? But okay. I mean, okay, what if you have a model? Okay, because you want to use models, right? You want to have models. Draw model. So you have your model that you load. Oh, that's why. Okay, okay, never mind. I was worried because you had like the... okay, never mind. Yeah, okay, GPT was talking about that. It's because... you know, in the previous example, you had like the draw cube every frame. But in this case, you just have like draw model with the model. And the model is an object that's been loaded with this. And it's basically probably pushing the vertices to the GPU at that time. And then it's just like, you know, coding the thing normally here. So yeah, it's fine actually. You won't have any problem with Raylib. The only problem is that you're still going to have to implement frustum culling if you want to optimize things a bit more. Yeah, Raylib stays, yeah. It does. Okay. What time is it? 5 a.m. That's fine. Okay. Cube chunk space observer. What was I even doing? I was doing this. So I should get a node. And I mean, it's supposed to be like a pointer or something. And we're supposed to have the value. I mean, the node is definitely going to be hard to find. Two chunk cards. Find chunk. Yeah, I have a find chunk. Yeah, the problem is that it's a node. So it's like actually used in the graph. I mean, okay, never mind. Technically, I should be able to do space, find. Okay, that's it. I got it. So do I have the repeat chunk graph? Yep. Do I have the traversal actually? Let me think about it. Raylib has backface culling. Yeah, backface culling though, because backface culling is implemented by the GPU, by like OpenGL and stuff. Like OpenGL has backface culling, not Raylib. Well, Raylib just exposes this. It's not implementing this. Like partial culling. Partial culling. I'm talking about frustum culling. So, I mean, I did ask the AI just before, but what I'm talking about is camera, advanced PBR in practice. Collisions, no. Wait, what? It's not OpenGL. Advanced, no. Face culling. Face culling? Well, that's backface culling. Frustum. Oh, I think it's in extra. It's actually my friend who wrote the article for the frustum culling. So code, guest articles. I think it was there. Frustum culling. And yeah, you have like a nice little video that's or maybe actually no, it was in my, wait, what's that? Radar approach. Okay. And yeah, it's basically, can I show you my game instead? Sicaria, Sicaria. Oh no, it's not my game, it's my engine actually. GP, let's go to this and projects. And we have this thing. Boom. And there is Wait, was the frustum culling at the beginning? No, oh, it's there. When I say frustum culling, I'm talking about this. Basically, because the quality is a bit bad, but everything is yellow is what is being rendered to the camera, and what is in red is not being rendered. It's like optimized away, so it's like very good for performance. Bruh, math. Can't stand it, but must use it. Yeah. I like math personally, but I understand. Okay, let's actually continue a bit. Get repeating chunk graph. Okay, I have this. I'm going to include modules, voxel, core, chunk graph. And now I can... Wait, let me do this. This. Oh, I have nothing in here. That's why. That's why. Yeah, that makes sense. Graph traversal. Wait a second. So I have nodes. I do have the nodes. Do I actually need this? I don't know. Maybe not. I have the hash map. Chunk to node. Oh, that's it. That's, well, data to node. That's what I need. Oh, that's gonna be perfect. That's gonna be perfect. That's it. That's what I want. And maybe I'm just gonna remove this. Node allocator. I definitely need to do something with this. Maybe, maybe not. So data to node. I need to Okay. Yeah, I mean I'm here, so that's fine. So I have this. Please. Right. So I can cast it, I guess. So it's gonna be this graph equal this thing. And that's going to be 2 like this. It's gonna be a... Do I want a dynamic cast just to verify? Because I'm doing this only one time a frame, and maybe it's better to have like a bit of a performance thing here, rather than, you know. Yeah, let's do that. A repeating graph. Wait. Let's go here. That means we need chunk graph. That means we need a virtual. Let's have this. And let's have, well, let's have this equals default, this equals default, and this one is virtual. And then we already inherit, which is good. And do I do node allocator? No, that's fine. So now I can dynamic cast to this. Actually, if I have the cube space, I can just get this directly. like repeating a graph. I mean, I guess it's private though. Hmm. I don't like that. Oh, is this? Yeah. Okay. I mean, I guess technically that's fine. Yeah, let's just have this. Space from chunk graph. Yeah, because we need the pointer. And we need this. And now we have a problem. Here we go. And now it's good. Right. It's like a bit hard to read, but yeah. Okay, so we have the graph. And now we just want to allocate a new node. So... Wait, that's not here. Here, we have this, we have... allocate. No. I mean, we still need the data, though. Find out create node. So we have this. Wait, I actually don't know how loud the music is. Sorry, I'm gonna do 2 seconds. I'm just gonna listen. Please talk. So we have this. It's actually alright, isn't it? Maybe not loud enough, I don't know. Okay, this is good. Okay, so Thunder creates. That sounds alright to me. Does it? I think it does. I think it's fine. I just need to call this when I need it, but this sounds good. And this is just going to be... Let's actually have this outside. Like here. Poof. Like this. The NB enables. Like, I guess it's N, right? But, wait, what? Incompatible? What do you mean? Huh? Anyways, should be good. Final create. So we're gonna allocate. Well, actually, no, not yet. Actually, a node. Yeah, that's not the OR ID, right? So we're gonna have this dot please load. That's gonna be a pain. A hash map. Wait, what's the deal with this? That's how you have a templated function, right? You know what? Let's do this. Okay, now it works well. Perfect. Yeah, I'm just gonna have this there. Yeah, I'm not sure about that. So we data to node. I try to get the pointer, maybe? Yeah. So we have this, the node. And if this is not null, we return the node, and else we create. So we are going to have create node. I mean, actually, let's just have this function for safety. So we allocate, like new allocation. We have a T that's, wait, node. Well, it's not good, it's not, right? I just have to be careful about that, but I have like no... Well, okay, I do have a lot of includes here, but should be fine. I hope. I wish. So we have this with a new node. We're going to data to node, yeah, is going to be get elements PTR, get insert new, and we want to insert the new value with the key being, well, the key is basically just this, right? Like data, maybe. I can take a constraint, and it's gonna be this. Technically, I should make this function. Technically, I should implement the right. How is it called again? R value reference and the L value reference. That kind of stuff, right? But that's not. That's not. Well, maybe not the L value reference, but R value reference, forward, all of that, but I don't care. So I insert new, and then I return, where was that? Yep, sounds good. Wait, I'm computing the hash anyways, right? Lookup index. Lookup index with hash. So, wait, it does use a hash. Wait, where's the hash? Hash here. So yeah, it's basically computing the hash 2 times, isn't it? That's what I don't like. It's not optimized. I can optimize this better. That's fine. I don't even know if the hash is that bad. Okay. Yeah, it's implemented for a lot of things. Yeah, it's just basically just a pointer, I think. It's not worth using. Like for a string it would be kind of useful maybe, but yeah. So we have the new node that we return. And then we just call this function with our data, which is going to be this, the repeating graph, like repeat graph t maybe. I guess that's the value. Well, the key. And we have the chunk, so this is the new chunk. We have, oh, this is perfect. This is so good. Is it? New chunk equals cube chunk. I mean, technically it's supposed to be a cube chunk, right? Cube chunk. And then we have the coordinates that are supposed to be Euclidean coordinates. I'm doing this, right? So chunk chords. I'm not sure about that. I think in is fine. If I just use this. And then I can find or create the new node. Can I? Const. Repeat graph t to a pointer. A pointer. Wait, what? T is a pointer. What is graph? Repeating graph. Oh no, it's not a pointer. Okay, so that's why there was a problem. Wait, I static cast to node star. Oh, and then I get the data, that's fine. Okay, no, that's fine. Okay, so that's why I had a problem earlier. So then I do this, I have the key that I put there. Then I get the node. Not like that. Like repeating node. Node equals this. It's a pointer. And I just assign it. Well, this is basically this, right? Yeah, I mean, I guess I can just assign it like this. Good. Very simple. O1. And yeah, I'm just gonna... Let me just actually go... Every time I have this paged allocator, I just forget about this. Press save false. And the page size is going to be... How many nodes am I going to have? I mean, a lot, really, right? But let's say 256. I mean, 256 for collisions. You know what? 512 should be good. And this one is not good. Oh, right. Gets PTR from the data. Okay, is it good now? I can't read that. Get PTR with this. Object type is something. Can I Can I do this? I can. So what is that about? Interesting. I don't know. Ah! Can I do that? No, I can't. Okay, let's just have auto v equal this. And then we have auto... What is that? It's not. Wait, so what's the problem? Maybe I should just get the index. It would be like easier, right? Header files and CPP in Godot. What do you mean by that? Craigasm. I mean, it's nice, right? When you want to do like some architecture and engine development. I'm still stuck on a type. I don't know why this is not... Okay, let me look at this a bit more. Repeat graph-T. No, detected during instantiation. What? You know what? This is, from now on, you are node. Okay. And now it should be good. Is it actually good? Wait, what? That's actually good? Is it because of this? Huh? Huh? I don't get it. Let's keep it this way. I'm going to have a lot of errors though, but that's fine. So I have this. This is great. This is good news. And I need to call this again though at some point when I do some stuff. Collision. Why is my collision? Huh? Collision Lambda. So I have all of this, and I have this too, right? I have the start with closest chunk, but what I should actually do is not get the current chunk, but get the collision chunk node. And this is gonna be chunk graph node. And now this is good. We can set this. And we can also... Yeah, how am I adding new nodes to this? That's my only question. We traverse. When we load, what are we doing? Found. Okay. Load. I don't understand. How am I setting... I get the chunk. And I just... Oh, I add it, but... Oh, no. I get it. Okay, I get it. Yeah, I shouldn't use, like, the... I shouldn't use this. No! I should put the node in there. As I was thinking before. So... From chunk space, though. Do I want an enum or something, because this is like bad. Graph. I don't want it to be in the graph. Repeating. Maybe I want an enum. An enum would be nice. I mean, I already have that technically, right? Like in, not in chunk space, but cube chunk space. I have this thing, tiling type. Wrap, right? So, let's go with something like, instead of repeating, because I have this multiple times, right? I could just get the graph traversal from, I mean, I do have the space though. Wait. Should I do something like try add a chunk from neighbor? Should I add collision chunk from neighbor? Wait. I just realized the vector 3 only has 3 indices. I mean, it's a vector 3, right? I guess. Well, 3 elements. That's the point. Explains why you can't do vector 3 4. I mean, yeah, you have x, y, z, right? That's like your point. I mean, you also can't do vector 3 3. Like, that's going to be crazy, I know. But indices actually start at 0. So you can't do this. You can't do that. I know, that's crazy. Is incompatible, blah, 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 blah. I'm just not sure about the shape all of this should have. But I have the new chunk. If it's not, we skip. Okay. I swear I did though. I mean, I don't know. But it's not supposed to work. So we're gonna have this. This is going to be the node. Try add collision chunk, maybe? Wait. cube chunk space. Right, we have this. Oh, I do have this. Wait, what? Yeah? Ew. And I instantiate a chunk here. Oh, right, because I did that in the parent before. Cube from... neighbor index. Wait, what? Yeah. Let's do... try add collision chunk from neighbor. And this is going to be a node. So... where is that? Chunky graph. Do I have a node there? Chunk graph node. Do I actually have this elsewhere now? So I'm gonna add this here. And this is gonna go here. Neighbor index. I don't know about that. Next neighbor index. Neighbor index. Wait, what? Oh, right. No, that makes sense. That's fine. I did for I in range, but the 3 is not included. It's excluded. Go size invalid access of index 3. When if yeah, because the loop stops at 2. It includes 2, but it doesn't include 3. Because range counts the total indices, that's where the confusion is. Yeah, that's like the end. Like you stop before processing the 3. Yeah. Incompatible with chunk. I'm not... Oh, try add chunk on collision. Chunk from neighbor. So I can go here. This one is gonna be virtual. For sure. And collision chunk. I mean, technically... keep. Yeah, technically it should return a node. Something like this. And then we override it in here. Try add all of this. We overwrite. And we're going to have some work to do. What I really don't like is that I'm mixing collisions with like the core, which was supposed to be independent. But well, maybe if I have a space, a collision space at some point, I mean, I could technically split it, can I? Well, I could technically split it, but yeah. I don't necessarily want to right now. I mean, I have no data to store. That's the thing. So let's do this. And neighbor index. So I mean we can, I mean I don't want to cast. So let's do T repeat. Well, I mean actually it depends. It depends a little. But let's do something like, I really don't know. So we have this. I'm actually not using this. Oh, right. I just have isTiling right now. Oh, right. Okay. They repeat graph. Node. Equal this. And I'm gonna static cast. I mean, I should make a macro that dynamic casts, and then in release we static cast instead. Sometimes my genius is almost frightening. So we have the data. What then? Wait. Try add. So we have this. Do we have the coordinates? Not yet. So we can do this. And then we can do this. So we have the from node. Data.chunk. We get the coordinates. Actually, we can just do dot calls, really. That way we have one less indirection, which doesn't actually matter, but that's fine. And it's cube chunk calls. I mean, technically I can do this. That's not a big deal, right? Okay. I hope. And then we have a problem here. Because we need a node. I'm probably just gonna copy this for now. Chunk, collision chunk from cards, maybe. Like maybe not actually. No. Let me think. Try add, maybe just node from cards. And we're going to have something like this. Node. And we're gonna go here. Well, we do need the chunk though. Don't we? Oh, never mind. never mind. Try add, boom. And we return the node. Well, I mean, technically it's supposed to be this, but that's fine. Can I do this? I technically can, because they inherit each other. Well, this one inherits the parent, which is good. So let's do this, please. Okay. Then we have this, we have this. Chunk cards. Yep. So we need a nudge. Well, I'm trying to add it though. I don't think I actually need anything else. Yep. Something like this should be fine. And as nodes, I actually still need technically the tiling and stuff, but nodes, not nodes. Let me think. I'm not sure. I mean, maybe I can use this finally. Tiling type. This tiling type. Boom. And we just have this, and it repeats for collisions. For collisions, it repeats. Good. So assert. Oh right, this thing. No, in this case it's kind of fine. Well, oh no, never mind. So depending on the tiling, we have to clamp, wrap, repeat. So we don't need this, and we want to, if it's clamp, we do this, please. Expected something. This. Well, oh, it's case, right? I forgot. So we have this if it's clamp. If we wrap, then we wrap, and if we repeat, then we just don't do anything, right? Technically. Do I have modulo pause modulo? Get neighbor chunk chords. Band. I'm not sure about that. But technically that should be all. Right? That should be it. Because like for wait. Wait, am I actually using this? Get neighbor chunk calls. I am. Oh no. Oh no. Oh no. Okay, this one is actually going to have two versions. This is good. So we have the tiling type. And we have this. We have this, maybe? Do we? Is valid chunk calls. What does that mean? I'm not sure about that. Yeah, I'm basically just going to switch here. Yeah, it's the tiling. So we have the tiling type. I mean, it's not really tiling type, is it? I don't know how to call it. We have, is it tiling? Then we modulo. So in this case, it's a wrap. Then we have a break. We also have, in this case, it's a clamp. Wait, what? What is that? Clamp and repeat. Let's have something like this. And if it's then what do you think? I do want an exception or like an assert when there's nothing, like the default. Like repeat is nothing, and then default is like an assert, like oh no. Kind of. Or like, I don't know. Maybe not, but an assert maybe? I don't know. Yeah, an assert. Right. Go to error C++. Well, show error C++ without returning function. Error fail. Stops the function. Use error fail or this. Without returning anything. Without stopping function is what I mean. Oh, error print. Okay, that's fine. Wait, do we have our print? Do I have like unimplemented or something? No, of course not. Like Oh. But compare, break, busy. What about Godot? No. Error unimplemented. Well, it exists. Instead of this, war print will always stop the function and return out of it. One print. And you just do this. But yeah, or unimplemented. Yeah, it doesn't exist. That's what I thought. So we have this. Oh, it's like for each, right, it's supposed to be for each coordinate though. That's going to be tricky. Hmm. It's like 5. I might just go to sleep because there's not a lot of people around. And that way tomorrow I will be able to stream a lot. So, rapid card. Let me think. Wrap, clump. I mean, I do want to... Oh, wrong one. The wrap is this. The repeat is nothing. And the clamp is... Well, it's just a clamp, right? Can I do this? Value, minimum, max. What am I doing? Yeah, I mean, a clamp is just, it's just nothing. It's just supposed to return null, isn't it? Like, try add not from cards. Wait, what? Why do I have this? Huh? Try add node. And then we have the get inside. Do we? Oh, well, okay. No, they're different. They're different functions. Never mind. I get it. But clamp is... It's not supposed to be like that, is it? I mean, that means there is no neighbor, though. So, like, we return null. Like, invalid coordinates, maybe? Cube chunk cards, cube chunk cards. Yeah, maybe we can just return, like, the same coordinates. Like that. Wait. Pause modulo. Current NV chunks. What about the plus one? Oh, this. Yeah, okay, never mind. That's fine. Well, basically we can remove this. Okay. Should be fine. And I'm gonna do this. And I guess we want this. I don't remember how to... Oh, wait, actually... Isn't it like something like... this, or... Wait, it is? Huh? Because, yeah, this doesn't work, right? Actually, it does. What the fuck? Actually, it does. That's surprising. Wait. Function with text array argument. C++. Cannot be passed. Yeah, but this style. Okay, this is it. Got it. Yep, this is good. So, like this. And you have this. Yep. Please. Please! I don't know. I mean, it should technically be fine, right? You have the type, you have the thing. And yeah, it should be good. And this one is... Well, basically we have the tidings, right? But it's basically just supposed to call the same function. Instead with the cards with this and with the tiding type. You know what? Let's just keep it like this for now. I don't want more errors by modifying things. And cube chunk, wait, what? Clump. Ah! Yeah, we return null in this case. Right. Yeah, that's fine. We repeat. Okay. So then we return the node. Okay, so now we have to instantiate the node and everything. So for that, repeating. Can I just do repeating graph dot kind of create node? And I need the data though. So we have the node. I can return it. But, well, not this. T chunk node. Well, T repeat node. Here we go, we can return. But the problem is that we need an argument, right? It's like the data. Repeat graph data. Can I just change this? T. No, just repeat graph data. Okay. Then data dot the coordinates. So potentially just well, cards equal this. Set chunk cards, okay? And then we have the new chunk, right? So we have to instantiate it. Is what we need to do. Something like this. I mean, technically I could just add everything to the graph just as I create the node, right? That's like a possibility. But I'm not sure about that. Data. So you have this, and then you have data.chunk equal the new chunk. What's the cube chunk? Okay, here we go, and it should be good. And now we are basically adding this to the graph. And well, we create it in the graph. And I guess I tried to find or create it when I don't know. Well, actually, it's been register chunk. Right. Oh, I'm supposed to add things to the neighbor there. Like, no, add neighbors. I hate that. Oh my god. Chunk space. So yeah, it's not even the cube chunk space. Right. Oh, do I have something there? I actually don't. Oh, I do. Yeah, I thought so. I'm probably going to stop here. So to do... finish registering the neighbors of the new nodes created in cube chunk space. Or can I actually just cheat a little bit and I don't know about that. One, two, three, four, five, six. So this is good. Wait, let me go here, right? I find out create. And now I want to get the neighbors and stuff. To do this. Technically. So I have the amount of neighbors. Okay. For each neighbor I do that. I find the neighbor chunk. And then I set neighbors. Oh my god. So... I mean, technically I can find that. That's not a problem. Well... let me think. Yeah, in this case, it's a bit different though. I mean, I have the chunk coordinates, so... Well, from the current cards though. I don't have the from anymore. Oh, no, never mind. I mean, it's not that bad. For every... Okay, never mind. For every... I mean, I do have the chunk that is called new chunk here. Technically, I can do that. I can get the neighbor chunk. I can get the conversion table. I can then do something like repeating graph dot data to node dot. Well, I mean, I guess find or create is going to be too much. I'm just going to find it. Like this, maybe. Find or create. I do need the... Oh, I can get it because it's a cube chunk, right? Like this. Okay, I'm going to have problems with this. Wait, what? Cannot create. What am I doing? Never mind. So this is this. I mean... Okay, you know what? If I do that... Let me actually do that in register chunk. Wait. Maybe I can just keep it this way and move that somewhere else. Let's go to... Wait. Chunk space? So yeah, we do have this. What if we try to get the... Oh, no, we don't have the coordinates, though. Oh, that's tricky. That's a bit tricky. Maybe after this, in register chunk still. Oh, thanks. Again, I want to go to sleep. Thanks for the raid, man. Actually, just a raid. We're back. Welcome back. Welcome back. Welcome back. It's Gaja's fault. I mean, thank you. Ho ho. 向かってくるのか。このレイドで向かってくるのか。では、十分近づくがよい。You can blame me. Let me... Did you get nudged yet? Nudged? Damn, that's voice acting. I have a big architecture problem. And I wish I could have... Blah, 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 blah. Yeah. I will have to drop out. It's sleeping time. Yeah, I'm in here too, right? It's like 6 AM. Parle en français, ok? Tant que ça? Tu veux que je parle en français tant que ça? But yeah, I remind that sleep is important. Right. Thanks a lot. Français times power 2. Puissance 2. If I run my... If I try to compile again now, everything is going to fail. I mean... Yeah, not... He made Minecraft. Yeah, I know. But, I didn't, like, eat a nut apple. Something like that. Wait, you call that a nut apple, right? Like a golden apple? Nut apple. Well, it's a very powerful one. It's like a nut apple. An enchanted apple. Future Microsoft is being born as we speak. Wait, he made... Oh. Nah. Is it? Okay. So I'm gonna register. We have the new chunk. We have the... What is that? Oh. This. Then we try to find or create, or just find. Just find. Yeah, just fine. So this is gonna be, what is it gonna be? I mean, I guess I can just keep this. Get pointer. And then I return... So if this is null, I return null. If not, I return the node. I mean, I guess usually it's like the opposite. If it's not, then I return the node. If not, it's null. Well, this. Okay, good. So now I can... Data? What? I mean, I guess. Wait, what was that? Cube chunk space, repeat graph data. Boom. We have the data. We put that there. We have the chunk. That is... Wait, I don't want to create. I just want to find. And how can I find? I don't know. Okay, so it should be data.chunk equal the neighbor. And then we have data.calls equal something else. I have to get the coordinates, so no. Alright. Neighbor index, neighbor calls. It's really bad. Wait, I'm supposed to... I guess I'm not. Oh, no, never mind. If I already have the chunk... Right, that means I can just get the coordinates. Okay, easy, easy. As. Pooh. But yeah, sleep well. I'm a bit late, but yeah. Set as neighbors. No. And more than everything, I want to update the graph. So let me think. So I have the node. Wait, find. Yeah, it's supposed to be a node. Teach-on graph. No? So repeat. Well, I can actually just remove this. And this is repeat graph T. We have the node. And we have the neighbor data. And now we have the neighbor node. And what else? What else? So we have this, and technically yeah, I have to clean all of this. All of this I have to clean. But I can do something like. I don't know. Neighbor cube chunk. Wait. So I have to get a node. So I need to do the same with like the current chunk. Graph data. We're gonna have the chunk. So cube chunk. And we have the coordinates. So we already have the coordinates normally. So yeah, something like this. And we find, and we have the node, like chunk node. And then if this is valid, we set them as neighbors. So, I mean, chunk neighbor index. Wait. This is complicated. But we are going to have... Let's just copy this, really. I'm just gonna copy this. I need to set as neighbors. So this. But instead we have the nodes. So what is it? The neighbor node. Like this. And then we have the chunk node like this, and we assign each other, so chunk node and neighbor node, and something is wrong. Oh no. So this is the wait, pointer. Wait. Oh, that's supposed to be... It's supposed to be an array of nodes, though. Not of data. So more something like this. Right? And now it should be good. Yeah, now it's good. Okay. My god. And it doesn't work for some reason. So we have this. What happens when I'm calling this? Neighbor index. I want to call this with like the tiling type. So tiling type. The problem is that I'm trying to do too many things at once. So I have this, and this is gonna be repeat, clamp actually. In Y it's clamp, and then we have a repeat. That's it, I guess. I'm hard coding the values, but that's fine. And try add node from cards. Get neighbor chunk card. Okay. Yeah, what about this one though? Tiling type. It's not good, is it? Tilings, nah, return now. I mean, I'm not sure about that. I mean, there's a lot of problems, but that's fine, maybe. Collision. Wait, this is actually good now? Okay. Wait, that's surprising. I don't have any error here. Wait, is that good? It's not good, right? It can't be good. But I think I won't be able to finish tonight, so I'm gonna continue that tomorrow. Hopefully. Wait, what about... How am I loading... Well, just the normal way. What about the clear? Well, it's just here. Right, it's for the traversal. You know what, I'm just going to restart and see what happens. And we're going to run without the editor because we're going to have crashes. A lot of crashes. And I'm probably going to stop there. Well, I say that, but I'm still going to continue for a while, probably. Is it even compiling? If it compiles... Yeah, it's not compiling. Okay. Okay. Yeah, there's like a lot of errors. Declaration of data hides a class member. So let's do graph data. Return cannot convert. Const. I mean, I guess it doesn't have to be const. And yeah, it should be good. Types pointed are to are unrelated. Wait, cube chunk to chunk. Huh? No, it's not. It's saying that because I haven't included the class. Boom. So now it should be fine. Yeah, I can keep it const, I guess. Well, it doesn't really matter. So data, let's what? Span? Wait, there's a problem. Huh? What? Yeah, that's fine. Get neighbors with this, span being compiled. Wait, so there's a problem there. Because it's not the same. Because of this. And neighbors is not what? Chunk graph node. And this one is like a lot of things, right? Oh. Data. No, it's a span towards... Okay, yeah, pointer, that's it. So that's good. Okay. Then we have this, we have data fixed, apparently. Okay, let's try it again. Let's try this again. Boom. No longer supported. What? Okay. Is not a member. What? What do you mean? Keep chunk space. Yeah. And repeat graph T. Oh yeah, it's the elements. Repeat graph data. Here we go. And now we have a problem with the in being cube chunk chords. Oh, I have to convert chunk chords to chunk. Yeah, that's fine. I can do that. It's cool. Well, it's cube chunk chords, I guess. Okay. Cannot. Yeah, I cannot convert from initializer list to... Huh? To span? What do you mean, initializer list? Chunk graph node. Pointer, const pointer. And then we have the size. What do you mean? Function style cast. It's not really... Oh, I think I get it. Let's do something like span. Yeah, let's split it. So then we have the span dot. Right. Maybe not. So wait, what can I... Film graph node. const this. Oop. We have the PTR. That is this, right? That should be good. And then basically we're going to have the right types. I think that's basically the problem. Yeah. That's it. That's basically the problem. A lot of problems. Yeah, I cannot convert, wait, what? From TY to this. Chunk graph none. So let me take a look at this. Oh, wait, what? Dot data. What is TY with this? I mean, technically, I guess. So, like, if I have... Okay, if instead I do... So that's an array, wait, that's an array of this, of size this. I mean, I guess technically I can do that, but I don't want to reinterpret cast. This is like so stupid. This is like such a stupid issue. Like, I guess instead I can do like 0. I can cast and then take the address. Like, would that be better? Like something like this, I guess. And then we have PTR. I guess that should work, right? Oh, wait, not... That's the address of the... Oh, that sucks. Wrong pointer. Okay, you know what? That's fine. I'm going to have the data and reinterpret cast it. Wait. Yeah, I kind of have to, I feel like. Boom. Because this is the same. This is like the same. This is a pointer towards stuff. Okay. Towards the list. Data. Graph data. Yep. Overloaded member function not found in cube chunk space. Who is a character in the YouTube icon? What? I don't know. It's like a triangle, isn't it? Isn't it a triangle? I don't get it. You know what? I'm just gonna have this instead. Because I know that this works. Right? Does it? It actually doesn't. You know what? Okay, let's try this. Const. Oh, it's not const, that's why. Oh, that was stupid. Okay, here we go. I mean, your YouTube icon in your YouTube channel. Oh, it's I mean, wait, technically that's Echidna, I think. Can I find it back? I can't find it, but believe me, I think it's Echidna. It's her. Because she's basically a witch that just wants to learn and learn and learn. And yeah. And I want to learn and learn and learn. See reference and wait. Ah! Class template instantiation being compiles. So this is not working. Hashes. Oh! Wait. Wait, so many problems. Binary equal no operator found, which takes a left-hand operator of quantity. I guess. So should I? Okay, it's for this one specifically. So let's implement this. Boom. Return chords not equal to this, and well, the most important thing is chunk is not this. Well, actually it's equal, so those should be equal, right? Initial value of reference to not non-constant as be a null value. What do you mean? Wait, what? Why is that that's supposed to be a boolean. And chords, no. Wait, that should be good. Value of reference. I don't get it. That's fine. That's a way if you you can say that. It's a symbol. Cannot convert from bool to bool. Oh, that was stupid. Your spirit animal, my spirit animal. I guess. I have to watch the new season of ReZero. I haven't watched it yet. It's a stream my Petri falls in a forest, and there's no one there to hear it. Did the tree fall? It depends if the tree is on a non-Euclidean planet or a 4D planet. Just kidding. What is that? Hash. So I do need a hash. For this again? Zut alors! Sorry. Sorry. How can I implement the hash for that? Hash functions. Hash map, hash default, hash funcs. Hash. So this is a function from Godot though. So if I want to specialize it, I need impl. Huh. Interesting. I really don't want to do that, but why not? For pointer types, and that makes sense. Oh wait, that's already a specialization though. If it's an enum, oh, okay. So yeah, the default is this. Or like, what is that? Impl. Yeah, okay. Let's just have. Wait, in our case, we want a very specific type. So let's have this. Wait. Can I? Wait. That's going to be a bit difficult, isn't it? You watch ReZero for the plot? I mean, yeah. Why? Plot is nice. I like the plot. Huh? What's... Okay. So there's going to be a few problems related to that, I feel like, but yeah. So then we have this, we implement the hash for this. Wait, it's a car array. Oh, it's a string. Wait, so let me just check this. Okay, yeah, then we have this. Got it. So let's go with this. Const. Can I just have a reference instead? It should be better. Yeah, we have a constref here. The constref. What about vector free, for example? Float, no. You don't have this. I mean, it should exist. Vector free, something like that. Wait, it doesn't. So hash. Const. This is good. Vector. And it doesn't exist. So vector free, maybe? It doesn't. I have no idea. Maybe vector free hash. Oh, here we go. Wait, this hash is inside. Oh, I guess you can have the hash inside. Oh, I like that. Wait, what's that? Hash funks. Hash murmur 1 real. What about vector 4? Because I might do things from this. Okay, you just fuse. Got it. I only know the pink-haired woman, and that's it. She looks like another character from another famous show. Oh. Let's remove this. And let's go back inside, and we're gonna have the hash here. And then real. I'm not sure about that, but what does that take? The seed. So can I technically have something like hash of the chunk? Too many arguments. What do you mean? Huh? Hashmap hasha default. Do something like this. Hash with the chunk. Wait. Yeah, we have the type. And that's not too many arguments. How? I don't understand that. And then we have the calls. So maybe something like this. I don't know if it's like the best, but it's like something, right? Calls W. Wait. X. Y. Z. Here we go. Okay, let's try again. I only know the pink. Never mind. Or maybe from the same show. From the same show. Oh, there's like Rem and Ram. And that's it. Wait. Oh yeah, that's what I thought. Does not take one argument. How? There's like literally one argument there. How is that possible? While trying to match the argument lists. Oh, it's... Oh! Never mind. Okay, here we go. Here we go, here we go. I mean, is that really the one I want? Because I don't think this is good. I really don't think this is good. But why not? Hash memo. Buffer. Compare. Whoa. Size primes in the inverse. Oh my god. Fast mode. Given the pre-computed C, much faster than N. Wait, you have that? What? Wait, that's crazy. I'm gonna keep this one. Hmm. I guess you could say that argument is making you argue. And blah. That's crazy. Of the product of two 64 unsigned integers. Well, what? It's crazy they have this. And we have those functions that are not implemented. Wait, are they not? Chunk space. Oh. Yeah, they're not. It's not. It wasn't. Keep chunk space. Override. This is good now. And yeah, it should compile and it should crash, which isn't really good. But yeah. 7. I really wanna go, please compile. I just don't want to stop in the middle of like a compiling error. That would be like horrible. Because that doesn't make me want to come back to the code. At least if there is an error and I have like some ID or not, even nuts of where it comes from, then, you know. Okay, it's gonna crash, Hey, it crashed. What is that? 0. Oh. Wait. That's... Never chunk. I mean, that technically makes sense. Because I was checking if this was valid here. So let's have something like this, I guess. And this is never chunk. Like this, I guess. Like this. Okay, here we go again. Okay, simple crash. That's not a big deal. Compiling. And here we go. Here we go. Compiles. Crash. It's not crashing. Wait, it's actually not crashing. Wait. There's the big problem. Okay. Register chunk. It's not a giant loop. So let's go out. Okay, we got out. Let's go there. Let's go there. Oh, we have a loop here. Oh. It's never increasing, is it? It's always gonna be 0. So if I put something there, it's never gonna stop. Okay. So where is the problem from? Plus plus. Let me go here. Let's go there. So we do this. We continue. Am I supposed to do plus plus? No. Wait, oh, there's a step, my bad. I missed the step. Here we go. So we get this one. You get the node. The neighbor is null. Oh, the neighbor is null. So we do request chunk load. And it can't manage to... Oh. I get it. So basically this is not null. But for some reason... Wait. Wait, what was that? New chunk. This is null. Data is null. Uh-oh. So if I go in, I have the coordinates. -1 and no. Oh, it's -1. Yeah. So we go there, we instantiate. Oh, I'm never setting this. Wait a second. Find or create. I'm supposed to set the data though. My bad. Data equals data. Yeah. Okay, that should be a lot better now. That was simple. I really want to stop, but every time it's like too easy to fix. So I just like fix this and hope that this is gonna be fine. But there's just going to be a lot of problems, isn't it? So yeah. That's a bit of a problem. Okay, 36 seconds. This is so long. Okay. So we have this. Is this... Actually, I don't know. But if I go there, at least now, we have the data that is valid, right? So let's just continue. And is it still looping? It is. Wait, what's the deal this time? Actually, let me continue just a little bit. I want to wait just a bit more to be sure that this is an infinite loop. Yeah, this is an infinite loop. Let's go there. So this is gonna be surprise 0. We get the neighbors. Okay, so the neighbor is going to be null. Yep, it's null. So we try to load it, but the neighbor is null. Okay. So we do things. We try to add it. We try to go there. We try to add it. We register it. Wait, I'm supposed to create it afterwards. Right? So... I mean, that makes sense. It's not gonna work. Let me think. I have this earlier. I have this before. So maybe I want to do that before, because then when I go here, I try to find this, but this is null. And is it like crashing? I guess it's not finding the neighbor, so it doesn't crash. But let's do this. Let's restart. And we need to go down and bring that up. Something like here, maybe. Wait, where is it? Okay. Here we go. It's a mystery how you remain hydrated for several hours without drinking water or stretching. I mean, I am. Look at this. This is crazy, and I'm like stretching too sometimes. But I mean, oh, my eye just ripped. But yeah, I'm good. I'm good at this. And I mean, the most important with I am not a good example of having a good posture, but what's important with sitting is not keeping the same position. So like, even though you can't really see it, I do move my back and stuff a bit. Okay, here we go. But yeah, I'm not a good example at all. Okay, infinite loop. So step. We have the neighbor that is null, of course. So we're gonna go back there. Oh, wrong one. Well, let's go here. We go in. We go instantiate. So we have the node. Okay. Then we register. We do things. And then we have this. So we have the node this time, which is good. Then we loop. We are not finding the neighbor. So we can't... Actually, we should find the neighbor at some point. Neighbor index. Yeah, for everything. So we should have something here. Not now, but... We're not finding. Let's go here. Let's go in. So we have all of this. Get neighbor chunk cards. So we have all of this, and then we have this. Let's look at this. So we have 0, 0, 0 and 25, 0, 0. So, oh, I know. It's because when I do... Wait, what is that? So we have this. This is 0, 0, 0. And then we try to get it. And we have it. Wait, so this is good. Right? So we go in. Then we try to find it here. Oh, that's why. And it's not... Yeah, it's not finding it here. Why is that? It's because I'm not adding this. This is only in try add nodes, not in right. Okay, let me do something similar in try add chunk. Wait, what was that? try add no from cards. We have all of this. So before the register, I'm gonna do that. And that should basically be it. You are drinking, wait, from an invisible glass of water. You can't trick me. Oh, there's some water. Look at this. There's some water. I just drank like almost everything. I still have some water, but there's a lot of water there. Well, everything is relative. Okay, here we go. And it's good. Oh my god, it's good. It's actually working. Wait, so we have surrendering, and we have no problem with that. Oh my god. Wait, so when I go down, I don't have collisions. What about here? I do have collisions here. Okay, this is good. This is good. So now we just have to debug the collisions, but we have the graph. We have the graph, and this is incredible. This is incredible. Okay, big good thing. So it's not even crashing. Oh my god, I didn't even think I would manage to get to a state without a crash. I just wanted to get to an interesting crash, but I wasn't thinking I would go this far tonight. So now I just have to check this. Wait, this is incredible. Okay, I guess this is gonna be it. Let's go. Let's go. That's that. Deck builder RPG. That sounds nice.
This I'm less sure about. The whole like.
Okay, let's raid, and this is gonna be it. Wait, so, yeah. Good job, thanks. And yeah, I mean, I still have the same problem as before, right? Like, I still have the same problem as I had, like, 5 hours ago, maybe? Actually, yeah, 5 hours ago. But yeah, it's a bit better. And I do have to remove the backface cutting, though. Well, I do have to add backface cutting, actually. Because I shouldn't see those faces. It's basically consuming... Like, if I remove those faces, I basically get ×2 for the rendering. Like, the speed. My rendering speed is gonna get, like, boosted, like, so much. So, yeah. To do add backface cutting. This is it. And yeah. I mean, thanks again, everyone. And see you next time. Boo. Wait. Boo.